Hey, golly, that button came on really quick. I only just pressed it. Good evening, everybody. Today is Tuesday, the 21st of January, 2019. Good evening, chat room. Everybody in the chat room. On the panel so far. Really quick, I only just pressed it. Oh my goodness, my thing's come on. Hang on, let me turn it off. I haven't done that in ages. January 2019. Turn it off. Good evening, chat. Oh dear, sorry about that. Anyway, on the panel tonight is our Patricia, Joe Hill, Dave Marsh, our Leah's joining, and maybe Flat Earth Dude. But good evening, guys. And I just forgot when we came on, you two know each other.
Yes, we do. Good evening, all. Yes, I met Joe at the conference last year. Yeah, I think we hung outside for a little bit and had a good chat. But there was so much going on at the conference, like it's, you know what I mean? You talk to one person 1 minute, then next minute you talk to somebody else, and then you're off somewhere else. And it was all a bit crazy, like, but yeah, I got to meet Joe.
Yeah, it was definitely crazy there. Like the amount of energy that was there was pretty interesting because people were so excited to see people or talk to people that like feels like you already know each other, kind of. Just like with Facebook and YouTube and stuff, you can really get I don't know, social media is interesting.
Yeah, what I've noticed is that you talk to these people, even though you've never met them in person, like you've known them half your life. You know what I mean?
Yeah.
It's before I even researched Flat Earth, I probably didn't even know the name of my neighbour's name until after about 3 or 4 years. You know what I mean? That's what it's like. And yet I'm sleeping at people's houses all through last year. You know what I mean? Just meeting somebody online, having a chat, then next time I'm at their house, sleeping at their house. You know what I mean? As if I've known them all my life. It's a crazy place.
Yeah, it's the subject of just flat Earth and all the things that people learn as they're learning about the lies, and then like people like Dave are doing, and I'm gonna say it, science.
Yes,
that's just something that the world is not interested in anymore, and so we're bringing it back, right, Dave?
Yeah, exactly. I mean, like I say, I didn't know anything about anything until 3 years ago, and I'm being truthful now. I didn't know anything about anything. You know what I mean? I just believed what I read and what I saw on the TV. And now when I watch the TV, I'm like, lies. You know what I mean? You can just see it. You know what I mean? All the programming, it comes at you. And like one of my favorite films is The Matrix, which I've always loved that film. Now, after waking up and watching a film like The Matrix, it's just a completely different film. You're like, wow, you know what I mean? I've really seen The Matrix now, and I just try to explain to people, you know, the difference in, you know, when you watch The Matrix when you're asleep, then when you woke, it's the two completely different films. It's like a documentary, basically.
Yeah.
So it's an interesting thing to wake up to something. Then
how many times have I sort of called you like our modern day scientist, Dave?
Well, you know, after like reading books like King's Dethroned, and you look at some of these way they measured the distances to stars and Mars and all this, some of the ways are really, it's embarrassing when you actually look back and see how they measured them. You know, using stellar parallax or using triangulation and using the Earth as a baseline from one point in its orbit to the next point in its orbit. You know what I mean? Having a 190,000 mile line baseline for a triangulation. Yeah, with a presumed Earth that's in motion. You know what I mean? It's ridiculous, and I laugh about it when I read about it because it's so funny when you know what I mean. They take a.
I was gonna say kind of like when we look up at the moon the other night when we had the eclipse, and when you look up at the moon and you see a darker part of the light part of the moon, and then everybody tells you that it's the ground beneath you making that turn dark like that. It just doesn't make any sense to me.
Yeah, I mean, I've questioned that a lot of times because, you know what I mean, they always put a lot of effort onto mention about the moon turning red, why it turns red. You know what I mean? When the moon enters the umbra, you know what I mean, it doesn't actually block all the light, which is absolutely nonsense. Because if the moon can block the sunlight on a solar eclipse, yeah, you know
exactly.
what I mean.
Yeah,
I'm sure that a ball Earth,
they choose what they
which
want.
is 4 times as big.
Yeah, and that's another thing too, is the solar eclipse. Like balloon footage of the solar eclipse that was in August of 2017, I think.
Yeah.
That was pretty interesting to look at that footage. But if you look at the size of the shadow, you know, on the Earth, or from a jet too, they I don't remember what airline they put out a video of, you know, footage that they had gotten, but it's a little shadow on the Earth, and yeah, I could get in. I just think it's all nonsense. It's all nonsense. I believe that
when Leah comes on, they were also looking at this, and they were going, it can't be. This is all wrong. It can't just be that little thing on there.
Yeah, I actually should try to find. I don't know if I have one. I should try to find a video that I could play of. I put a GoPro on just the hood of my truck pointing up. In August of 2017, I went to Nebraska to watch that, or to film that solar eclipse, and the shadow of the eclipse, like time lapsed, it's so distinct on it's so crisp on the edges that it almost looks like you're taking, I don't have a lens here, like sliding over a lens over the camera.
Yeah, it's just too sharp, isn't it? The edge of the apparent moon is just so sharp, and there's nothing to that edge at all. You know what I mean? But then again, what I did notice when I was looking at solar and lunar eclipses is that the moon is always 100% during a lunar eclipse, and it's always 0% for a solar eclipse, and it always stays at 100% and 0% for an extended amount of time. Now, back on the July lunar eclipse, the moon was full at 100% for 11 hours 46 minutes. You know what I mean? That's a long time to stay full for an object what's in constant motion against a fixed sun. You know what I mean? It's a hell of a long time, that is. And there's no way that fits the heliocentric model. I don't care if you say, yeah, it's because the alignment's perfect at that point. Yeah, it still wouldn't stay at 100%. He only stayed at 100% for 9 hours during this one, which was interesting.
Which is, you're saying, like, as how do they determine, or is that something that you can do with pixels, or how do you determine the percentage of?
I mean, to be honest, I'm just doing it by what I viewed, because I followed the moon from 99.6% up to 100%.
Okay,
and you can see that just got a slight little bit of a crater on the edge, and then it fills out a little bit. It never looks perfect, but you can tell the difference between 99.6 and 100. And I'm just going by moon calc and time and date for when they tell me it's 100%. You know what I mean? Because that's all I can really do. Like,
well,
but it is
that's
interesting.
what I was just wondering. I'm trying to find a video here for. It'll take me a while, but hopefully I can find one.
Yeah. So, like I say, it's for it to remain at 100% for that amount of time. It just doesn't fit the heliocentric model, and it's a question that I've asked a few times, and I haven't really got an answer for it yet, because nobody seems to know why it would.
Yeah, and to be honest, the things that we see up in the sky, there's a lot of people that claim that they've been up there and all this stuff, and sure, maybe they have, whatever, I don't care, but there's a lot of things up in the sky that we're taking too much human pride in and acting like we're doing it. Like, yeah, we know how it all works, and to me, we're observers from the ground. Do you know what I mean? I think that's like heaven. I think it's heaven. Whether or not they're going into it or not, I don't know. I'm saying I think it's heaven. I don't think it's space. But that's me.
Yeah, there's, like I say, there's what is interesting as well. What I did a post on Facebook today is because when I was obviously on the night of the eclipse, I was ready for it. You know what I mean? I was taking shots, trying different lenses from 4 in the afternoon right through till 5 a.m. the following morning. I stayed up all night. I had the day off work. You know what I mean? But it just happens that the cloud cover came in at 2 a.m. You know what I mean? But
Yeah.
what, just to rub it in, when I got up this morning, there was a big bright moon there at 5 a.m. You know what I mean? The day after, and I'm thinking, sod's law, innit? Why couldn't it just be clear up for that? Because I didn't really wanted to get that eclipse, and it was quite depressing when I didn't get it. But when I was waiting for the moon to come from behind the clouds, what I did do, I thought, oh, I'll go and see what NASA's got to offer. You know what I mean? So I went on to Google and YouTube and started looking for NASA's footage of the eclipse, and they never covered it. I'm like,
which is weird.
The biggest,
I saw your post on Facebook.
Yeah, the biggest astronomical event probably of the year, and they didn't cover it. And not only that, when you look at the path of the ISS over the last few days, it clearly
a couple times.
It clearly went through Europe and through North America and dropped down into South America at least twice during the eclipse. Now, if you see the photographs where I posted of all the optical equipment that they carry on the ISS, it's got about 80 cameras there. I'm talking proper photo lens cameras, you know what I mean? These massive things like the paparazzi use, all hanging around and floating around there, and not one image of the lunar eclipse. Because what's interesting about a lunar eclipse is as well, it's not based on the observer's position like a solar eclipse. You know what I mean? A solar eclipse requires the observer's position, whereas the lunar eclipse, it will take place for everybody at the same time as long as the moon is above your horizon. So, you know what I mean? It doesn't. So from outer space, they would have still seen the full lunar eclipse if they was there at that point in time.
They would have had a sweet view, actually, because they're up higher, out of the atmosphere, you know?
Yeah, well, I did search for some pictures of the moon from the ISS, and yes, they do have a good shot of it. You know what I mean? You've got one where it's setting, but to be honest, the footage is not as good as like where we're capturing. if I'm honest, you know what I mean? Did
you see that footage that I took with my P900 of the solar eclipse, and I zoomed in on the, like, I don't know what they call it, the prominences or whatever. Looks like fire kind of coming, but
I think you showed it last time. It was great. It looks like the flares. They don't have a bit like
why doesn't NASA have any footage like that? Or do you know what I'm saying? I just by chance I zoomed in and I was like, what am I looking at here? Because I'd never, just like you a few years ago, I didn't look at any of this stuff. You know, I just hadn't. So I guess my question is, why doesn't NASA have some better footage? Or like, I don't know if you saw the video I took through my telescope of Polaris.
That was brilliant.
You can get up close to Polaris and you can see that it's like red, white, and blue. I mean, red, white, and green. Sorry, not blue. And I guess I'm just, anytime you go to an observatory or anything to look at a picture, just an image of a star of Polaris, all you see is just a bright dot or like a point of light. But when I look with more than one camera, when I look at it, it's green and red and white. And it's like I can't describe what it actually would look like or something, but it's a light in the sky that is green and red and white. But
yeah, interestingly as well, while I was shooting the moon on the night of the eclipse, Sirius were out, and I got some single shots from Sirius. But what I did, I turned the shutter right down on the camera, so I got short bursts. You know what I mean? I blocked out quite a lot of light, and I got one blue star, one green star, one red star, one light grey star, a purple star, you know what I mean, and all single shots. It looks quite cool.
That's
on
awesome.
Single shots, yeah. So that was quite cool.
Oh dear, I tell you, I was looking at my app the other day trying to suss out the Big Dipper and things, because I just don't think I think it goes round. I think in the summer it goes round twice, and I think in the winter it's going round not once, but it's slowed right down. Anyway, I was looking at it, and the ISS space station was below ground, and it was just going round and round and round on my app. It was just going round and round and round. It was so funny.
Yeah, I know you've caught some good footage of the ISS, Joe, haven't you? I've caught it a couple of times, but it's always been.
It's hard.
I always try and get prepared for it, but you just can't, can you? When you see it coming, you're like, "Damn, it's here," and you stop panicking and
You know,
start.
I had an idea. Like, you know how a sundial works or whatever. Just like, if you had something like that, something with a, almost like a device that would go like this, and you had your camera on there pointing up, and you could carefully on the ground with a compass or whatever, you could set it to be. I've thought of this. I've never done it, but you could set it to be in line with where it's supposed to go because it's pretty accurate where it shows up and everything.
Yeah, I'm wondering if an equatorial mount would capture it.
Yeah.
I know it'll. I know. Obviously, once you set it up, it will track the star or track the moon or whatever you want to track with it. But I don't know if it'll track the ISS. But it'd be interesting because then you'd be able to concentrate on the actual focusing on it. Like,
here's something that I don't know if I've ever mentioned to you, Dave. I don't think, but when the ISS goes over, I'm always watching it. It's always coming over from over there, and then it's going that way. Now, when if I was to do a time lapse, you know, if with a fisheye, so you could see the whole thing or whatever. But if I had it in the center, it's still going to be a curved line. Okay, that what I'm saying is it's a curved path. So if we set up a device that was like a perfectly straight line that would, you know, that the camera would be on, that would go like that, it still won't work. We have to have like a curve. But tell me this. I'm sure anyone that you'd ask that lives on the globe, they would say, "Oh, that's the Great Circle," or what, or the, I don't know exactly what the word they use is, like the greatest, a straight line around the globe. You know what I mean?
yeah. Do they call it? There's a name for it in there.
Great Circle route, like
that's it. The Great Circle route. Yeah, yeah. They say it was following that.
So what I say though is that Great Circle route is, they say it's a straight line, but
yeah, well, it would be, wouldn't it?
Going around a globe. But what about, why is it not a straight line over my head then?
Yeah, it's interesting.
From horizon to horizon, if you draw a straight line, the ISS is going to go out of that straight line and then back into it.
And not only that, when I shot it, I see it 3 times in one night because obviously it passes about, I think it's every 90 minutes or so.
Yeah, I think you get two times usually, or not usually, but sometimes, or maybe maybe 3.
I got it twice, but the third time it came, then it disappeared just before it got south. You know what I mean? It was like literally going away from me a little bit, but the first 2 times it went straight over my head. And what is interesting when you think about it, if it was going around a ball, there would be a time, where with the ISS being 4 millimeters off the beach ball, should we say?
Yeah.
There would be a time when
I like
the Earth would be actually blocking the light from the sun, wouldn't they? You know what I mean? But yet you still see what they're saying, the solar panels are still being lit up by the shine of the sun, which it would be obscured by the ball Earth. You know
and the atmosphere and all that. Now, you know what?
Why isn't it glowing red as well?
Well, and then here's the thing is, I have some footage, and I haven't even made it public or anything yet, but it was just footage that I took, but I was just handheld is the best that I can film that thing with, like my P1000. I can't do it on the tripod. I've tried. It's just not as easy. But
can I just say Karen B put in the chat room, hang on, I'll just put it down because I copied it. Hang on, she put, get it right, the ISS moves too fast for a celestial tracker to track it. You have to do it manually.
Okay, yeah, and I think she's probably right. And then like I was saying, you'd have to build like a specific mount that would actually not only go like this, but it would also go like this. You know what I mean?
It's got that curved where it like literally curves away from you, doesn't it? Yeah.
Because if you want to zoom in on it, you know how touchy it is to keep it in the frame is hard. So it's hey, I see Oddity in the chat there.
Chat room.
Yes, it is a difficult object to shoot, and you know what I mean. I've tried on a number of occasions, and I probably got it best once with my camera phone, where I literally just see it and I just put my camera phone up to it, and obviously it's a lot easier to just hold the phone there on it. But
Yeah,
what I had trouble getting it into the actual camera at the beginning, you know, to actually pick it up, you know what I mean, from a
yeah,
distance.
it's too dim, and then like when you can't see it on the viewfinder or like looking through. But I guess, yeah, it's one of those things. That's why I hold the camera, because I can kind of like use my other eye to
Yeah, that's a problem.
get it to the right position. And then once I see it, usually I can stay on it for a while.
Yeah, when it's dark and then you're looking at that bright screen, if you look at your bright screen, then you look away, you can't see anything. You just see like a blue light in front of your eyes, can't you? So that doesn't help either, because you're in the dark and you're looking at a bright screen, and then you're trying to find this object, what's coming over your head. So it is a tough one.
One of the last times I filmed it, probably like maybe 2 months ago or something. Well, first of all, there was a deer behind me, and I could hear him like going, like snorting at me, and I'm like, I hope he don't come like, you know. So I didn't film it very good, but because I kept like freaking out that I was good, because he kept like, yeah, it was weird. But the ISS, like, it'll show up over there, and then it'll go like this, and depending on, like you're saying, depending on when the sunlight's gonna hit it or stop hitting it, and it's like almost right above me, and it disappears. But as it disappears, it goes from white to, you know, like a glowing orange, and then to a red, and then it disappears. And I actually got really decent footage of that that time, and so I have to like slow it down or whatever, and it'll still be all shaky. But sometime I'm gonna get that put out.
Yeah. Also, what is interesting, what I put a post out a few months back, was the Parker Solar Probe. Now, it took its first shot of Earth when I think it was 18 million miles out. So it took its first shot at 18 million miles out. So why didn't it take a shot at 18,000 miles out? Yeah,
well,
it would have had a beautiful shot of the Earth, and did a flyby of Venus as well at the time, and still never took a shot. That's
messed up.
Beyond a joke.
Well, their camera on there it doesn't like it when you ask it to take questions or take pictures. It takes them when it wants.
How convenient.
Yeah.
But people
just
don't see it, do they? You know what I mean? They're just blind to it. And if you go onto the NASA website when there's like a rocket launch or SpaceX, some of the comments, I'll tell you something, it's sickening. It really is. You know what I mean? These people, oh, they love it.
I mean, like if you go, same thing with SpaceX. If you go look at SpaceX, you know, comments, or a lot of times they turn the comments off on stuff. But if you go look at where they do have comments, it's like two kinds of people that comment. One is SpaceX is awesome, like Elon's God, and then they got the other people are like us. We're like fake. That's all we need to say. One word.
Yeah, interestingly, there's a new film on Netflix called I.O. It's based on that people have gone to live on one of Jupiter's moons, and the woman who's still left on Earth, what's been destroyed by man-made global warming. Well, she's still in contact with him, and interestingly, his name was Elon.
Oh yeah, that's right.
The character's name was Elon. It was quite interesting.
And then, are you talking about that Werner von Braun thing, or is that something different that you're talking about?
No, this is a new film called I.O. which
on Netflix.
Brand new on Netflix. Yeah,
weird.
Yeah, she's like a scientist's daughter, and she's trying to survive on Earth while it's dying.
Was it you that put? Oh no, it was I can't remember his name. I shared somebody's picture that I saw where they had that star hopper that they were building for like testing, and it had Wile E. Coyote up there with the Acme book, you know.
Oh yeah, I know what you mean. That big silver 1960s rocket.
I might have the picture. I can put it up in the background or something if I find it. That's great though.
Yeah. That is great. That it's best when they put it together, just like a big hollow end of it, weren't it? You know what I mean? Just this big crane's picking it up and just plonking it on top. It would just look like
I do have some images here. I gotta find a good one though. That's great.
Well, I think we're all in agreement here. We all do videos about NASA, don't we?
Yeah, good old
Yeah.
NASA.
What did Karen want to say anyway, Karen? Because you didn't get to tell him.
Oh
Oh
yeah.
no, she said you had to take it manually if you wanted to see take a picture.
Yeah, well, that's what I always do anyway when I shoot the ISS. Because if you just get like a big blob if you do it automatic anyway.
Yeah.
So
I've done I have a D5000, I think. It's not a very good not a very good, it's a little older of a camera, but and the IP or lens, whatever you call it, I have on there is not like a real zoom lens, but it's got a big image. So I've taken and done still images of it that are, I mean, really far away, not zoomed in very much at all, and then zoomed in on the image and got decent images, but not not too hot. But I've put them up on Facebook and stuff. They're not. You can tell it's like it, whatever it is. It's trying to look like that.
Is it like a little square? When I try to pause my video, all I got is like a little square. It looks like a little bright square.
I might be able to, if I have some pictures of it here. I'm just kind of looking through some pictures to try to find some. But if I have some, I'll put them up.
Dave, I've got a message for you. Crowxe said he'd like to chat with you after.
Oh, cool. Maybe you can come into the chat and have a little chat then. So I know he always comments on some of my videos.
He's in the chat now. What you mean on the Hangout?
Well, if he wants to join afterwards or have a chat in a bit, it's up to him. I know he's been asking me, like, but you know, it's like I've going back to work after Christmas. It's been a bit hectic because we've got some new work and we're taking on 2 new starters every week. So it's just piles and piles of paperwork for these new starters. You know what I mean? Because you have to be do all these safe systems of work and all these standard operating procedures and get trained on mechanical handling equipment and what have you. It's a nightmare. So I've been really busy, and like I say, I'd literally come home, went to sleep, and I got up about 15 minutes before I come onto this hangout because obviously I'm on earlys, so I want to be able to stay up a little bit later tonight. So
I thought you were a bit different because I had seen that you'd not really been to your messages lately. I thought maybe you were working.
Yes, it's been a bit hectic at work as well because, like I say, with these new starters, it is really, really hard work because you've got to be on top of it. You know what I mean? So I'm trying to balance both at the moment, trying to keep on top of the new starters and obviously do bits and bobs. But I'll be joining Dr. John D in February at Worthing and Brighton to do that refraction test. He's doing like a laser refraction test. So that should be interesting. And if anybody's available, I think it kicks off at Worthing or Brighton Pier on February, I believe it's the Saturday, so it's February the 2nd at 3 p.m. So that'll be pretty good. So I'm going to go down there, take some equipment down. And the good news is, after I've been down there, I'm going to get my camera made full spectrum.
Oh yeah,
yeah. There's a place in Norfolk. What'll do it for me for £300. So
Adam says see you there. Adam Meakin says see you there.
Oh, cool! Yeah, if he's going, I'll meet him there. I've met Adam as well.
Just back to Crowxe. What do you want to do then? Do you want me to add him or?
Well, it's up to you. It's up to you, Karen. If you wants to come into the chat,
I don't know.
no
Crowxe. Message in the chat room. Sorry, carry on. Joe, again, there you are. He's on the ISS space station again.
Yeah, I love some of the stuff you do on with the camera, mate, because I'm like, how the hell do you do that? You know what I mean? I can't even do a live feed Facebook.
$50. $50. It's a program called, what is it called? Sparkle Cam. They need a marketing team, but it's called Sparkle Cam, and you can try it with the watermark before you buy it. So
yeah, I was trying to get some measuring software for like 6 months, and I had to end up paying for it, and it's not cheap.
I bet.
You know, so I can measure the moon or the sun or measure anything really. You can actually pump in formulas and have a overhead bird's eye view of a a city and measure the streets if you wanted. You know what I mean? If you've got the right formulas for it. So it's a good little tool. And it's like I say, it's helped me out a lot, because that was locked at 640 resolution, which is quite poor when you know what I mean, when you want to be quite accurate, especially when you've got 20 megapixel shots. They look really grainy and horrible. And when you're putting them on the big screen, if you're doing a presentation, it looks really poor. So it's good to have the full resolution and the full image now, where I can actually measure the full image and get a really, really accurate measurement instead of a 640 pixel related measurement. But only thing is now, because I did all my old measurements at 640, I've got to go back and remeasure all the other ones I did, which is going to be a nightmare. So, but I'll get there, and like I say, what I'm going to do straight after this hangout is I'm going to measure these moons where I took them at, on the hour from Rise, and what I'll show hopefully is that although the moon looks massive when it's on the horizon, because it got me a few times, and I'm saying there's no way that object is smaller, yeah, when it looks absolutely huge, and I'm talking huge, because I saw it rise on the day of the eclipse, because it rose at just after 4 o'clock, and it looked absolutely massive. And I got it about 15 minutes later, because I was coming back from my mum's for Sunday dinner, and I thought, wow, that looks big. But every time I've measured it, it's always measured smaller, which is quite mind-boggling.
And you're talking basically measuring with the pixels. It just, when you're outside, it appears to be a lot bigger, but then
yes,
when you get on the computer and measure it, it's actually smaller.
Yeah, I always capture it at 1440 millimeter. Yeah.
Okay.
So
then
I
you're
always
kind of
keep
used to the same size.
Yeah, because that's the optical zoom on my camera. So literally, I just take it to optical zoom and snap the shots there. And every time I've measured it, it measures smaller. So even though when it's right up in the sky above your head and it looks really, really tiny, it measures bigger than it does when it's really big on the horizon, which is like completely opposite of what.
Doesn't that kind of go against what everybody fighting against the flat Earth? Well, that's what they always say, isn't it? Oh, it doesn't change size. It would have to.
It does relative to the size and distance.
Yeah.
You know what I mean? They say, oh, if it was smaller and closer, it would disappear like a little dot. But then again, they're not thinking it's relevant to its size, to its distance. You know what I mean? They're saying it's 238,000 miles away and however big it is. And I'm saying, well, no, if it's closer, it'll be smaller. You know what I mean? And relative to the size and distance.
Yeah. Yeah, that's, I don't know. I think to me, it's all like something that we've kind of, as human beings, we've kind of gotten in this weird funk where we know that we have a way to figure that out, how that works and what makes that happen and how exactly the results and how everything will be. But really, I think it's a mistake, because we have table of elements and we have a lot of information that we know about things. But like when it comes to, I always use this for an example. When the clouds are in the sky, that's water, right? And why does it not fall? And then, of course, we have this scientific explanation of, oh, well, the particles build up enough until they're big enough for a drip, and then they fall. Well, how about this? No, God just does it. Like, I'm not saying that the science is wrong, but what I'm saying is, at a certain point, I think that it's like we're taking the credit away from the one who made it,
Yeah, like I said, they tell us that everything is attracted to everything, but clearly that's not the case when it comes to clouds, because you've got trillions and trillions of gallons of water above your head.
Yep.
And it's not having no effect.
And
the
one way
is having no effect on it.
Yeah, no, you're right. And one way to prove that to yourself is to take a 5-gallon bucket, and one time when it rains, take a tarp or something and kind of prop it up so that it runs into the bucket and pick up a little bit of that rain, then pick up the bucket. Tell me how that bucket of that weight was just sitting up there for 6 hours, and then one second it just started falling. It's
crazy. Yeah, the force of gravity. Well, even if it, like I said, they say it's a force, but a force needs to be caused by another reaction. You know what I mean? So it couldn't be a force anyway, because they can't explain to you exactly why this force does attract one object to another object. You know what I mean? It's it's all nonsense.
Or demonstrate it. I mean, they have their Cavendish experiment, but that just doesn't work because there's too many, like what's his name? Daniel Pratt. He was making a video that I don't know if I watched the whole thing, but he said something like, what about static? What about, a lot of these other things that we do know about that? So you can't use like really any material for like a Cavendish experiment or whatever to actually prove anything with it.
And interestingly, in my clipboard at work, which is plastic, if I put any paper in the actual clipboard, what it does, it gets sucked up and sticks to the top of the actual clipboard. It's one of them you can open up, you see, and put stuff inside. And you know what I mean? The static in there actually drags the paper up and it sticks to the top of the clipboard, which is quite interesting. You know what I mean? It completely defies the force of gravity.
Yeah, kind of like helium.
Yes. So, like I say, with the force of gravity, it's very selective, and the word gravis actually comes. It means weight. You know what I mean? That's where the word comes from. I don't know if it's a Greek word or if it's a Latin word, but it comes from the word gravis, which means to have weight. But there is no weight involved in the force
it's all
itself.
Relative. I'm just kidding. I just always say that. It's all relative. Relative to if you believe your own senses or not.
Yeah, so objects with gravis will fall due to their weight. You know what I mean? But the stars will be kept in their positions. Well, I believe with electromagnetism.
Yeah, I think that the sun and the moon and all that. To me, I mean, like, I don't think the sun is like a necessarily an object like it looks like, but whatever it is, I'm just saying like it's obviously has a perfect, however it goes, it has a perfect cycle. Like every day it comes around again, and every year it does that switch, or it goes through that cycle every year. So
yeah, and like I say, it's interesting when you compare the sun to the sidereal, and the sidereal is like literally 4 minutes faster each day. You know what I mean? It doesn't really fit. They say it's because it's actually the Earth is actually moving in its orbit around the sun.
No, the sun's moving faster and slower, right? From the ground, right?
Yes, yeah.
Yeah. So
I understand that Crowxe joined us. Crowxe's joined us.
Hey, how you doing? All right.
Yeah, I'm good, Dave. Yeah, how are you all? Thank you all for having me in.
Pleasure.
How you doing?
Nice to meet you.
Yeah, I'm good. Nice to meet you too, Dave. It's the first time we can talk like this. And Joe, I'm so glad what you said about the Cavendish experiment. That was the first thing I thought of, the static and these other things about the Cavendish. So yeah.
Yeah, and it's such a sensitive, or it's such a it's too sensitive to actually really prove anything. And then again, we can disprove a lot of that kind of stuff with, we can scale things down. And I guess what I'm saying is that gravity is a theory that came from, well, look at this thing behind me. This orbiting NASA like that. That's the whole idea that they came up with. Or who was that? Copernicus, or I don't know who it was. No, it was Galileo, maybe. I don't know.
No, it was Copernicus. So obviously,
was it looking up at Jupiter? Up at Jupiter, you look up there and there's moons going around it. And to me, my belief is that they're holy angels, like guarding it, like because my understanding is that it all the other stars, they circle around Polaris, every other star except for those 7 planets. And so I think those 7 planets are the ones that they transgressed, because they were supposed to be going like that, like all the other stars, and they didn't do what they were supposed to do. And so that's, I think, is like they're in prison, like they're jailed where they are. But
Yeah, it's quite interesting when you look at the stars or the so-called planets as such as well, because like Mars, I don't know if you've noticed, but it's literally been in the same position nearly since beginning of summer. I noticed it since it was at apparent opposition when it was really, really bright in the sky, and it's just I've just noticed it now. It's getting higher and higher and higher in the sky, which is quite interesting. And then even though I tried to catch it with the camera, I tried to capture Uranus. I know it's quite funny, but Uranus was supposed to be at opposition as well, and
I'm just kidding.
I couldn't even see it at all. You know what I mean? Even when I took a long exposure with the camera, just a one shot, it doesn't show up. So I don't know how the hell, with the technology they had like 300 or 400 years ago, that they managed to pinpoint that planet. You know what I mean? And then to say there's another one.
What about a different time of year? Would it be maybe easier to show up, or you know what I mean? Would it show up more on your?
Well, no, because that was opposition. That was its apparent closest point. You know what I mean? So, and
so that would have been the time that it would have showed up.
Yeah, that was the time. That's why I tried to shoot it. You see, because it's the mainstream is saying, yeah, it's visible now and it's at opposition. It's at its closest point, so it should be visible in the night sky. But with the equipment I've got, you probably would get it with a telescope, I reckon, but not with the camera equipment we've got.
I just know that I think the only ones I've filmed is like Jupiter and Saturn and Mars and Venus, and I think that might be all that I've filmed.
And think about Mercury as well. Mercury's supposed to be the closest planet to the sun. Now you'd think that'd be one of the brightest, wouldn't you? You know what I mean? But it's very, very rare. You see it. I mean, I've only seen it on one picture where someone's took a picture of Venus and they just managed to catch a faint star, and that was apparently Mercury. You know what I mean? But there's no, with being that close to the sun, surely that would be one of the brightest, along with Venus. You know what I mean? Because I'm sure you've seen how bright Venus has been lately. It's been unbelievably bright. You know what I mean?
Is it a crescent right now? I've gotten Venus.
It's like I think it's like a waning gibbous now. Actually, you know what I mean? I think it's gone past the halfway mark, so it'll obviously soon be a full view. But I'm not sure we'll get to see that. I'm not sure how it actually works. But yeah, like I say, it's so bright in the sky, and when it was like a little crescent, even when it was a little crescent, it was super bright. You know what I mean? It was like. Definitely. Yeah, because when you turned the shutter down on the camera and took a shot, it was just like a I don't know, like a 10% waxing moon. You know what I mean?
Can I just say something to you, John? I don't know if Crowxe can stay that long. Crowxe, did you want to ask Dave something?
Yeah, I'm here. I just I wanted to say that I was looking continuously to the moon race video, and I did found some conflict. It's not the same conflict that you, Dave, pointed to, but there's another thing that I cannot explain, and I asked some Globers, and they cannot explain, and I was hoping we can get together. I share what I found, and we discuss it.
Yeah, that'd be great, because there is a lot of questions asked how I measured the speed of the moon. Now, the only way I can possibly measure the speed of the moon is to measure it over a long distance of time, and measure it at my zenith, and then measure that time in between it takes to get to that same spot every night. Now, I know that might sound crude, but when you pump all that information into a graph, what you do see, you see quite a lot of changes in the speed of the moon over a year. But what I did notice is when I highlight all them deltas above 24 hours, it worked out at 50 minutes, which we all know that the mean time of the moon is 24 hours 50 minutes. You know what I mean? That's the average time it takes. It varies from 24 hours 40 minutes up to nearly 25 hours. You know what I mean? Sometimes. Now, like I say, it is a crude way of measuring the moon, and it's the only way I know, or how I could measure it. You know what I mean? People say you need to measure it against the stars. You can only measure it on a a solar eclipse or something like that. But when you look back at astronomy and how they measured the distance to certain stars, using parallax and stuff like that, where you've got like a millionth of an inch of parallax, which is absolute nonsense. You know what I mean? It's more likely the equipment that they're using is not accurate, because when you're talking like a thousandth of a cigarette paper in length, you know what I mean? So, but yeah, like I said, with the moon race, it is a crude way to measure the moon, but I find it effective, because every time I've shot the moon on my viewfinder, and you do see that slight change in relative speed, it always matches up with the meridian passing time, which for me is strange. Now, I've asked the question a lot of times, and I've asked it on your show, Karen. What if I am doing something wrong? What am I doing wrong? You know what I mean? And I've never had an answer. I've had people say, "Oh, you're measuring the rotation of the Earth." Slyman Dan says I'm measuring the rotation of the Earth. Now, we all know that the Earth is fixed and it doesn't rotate. Yeah, so clearly I can't be measuring the Earth, especially when I'm taking the deltas over 24 hours. You know what I mean? So, like I say, if anybody's got anything they want to add to that, then you know what I mean, I'm always open to question. You know what I mean, I've been wrong in the past, and I'll probably be wrong again. But you know what I mean, every time I have been wrong, like in my first presentation when I measured the moon and it actually measured smaller when it should have measured bigger, I went back and I measured. I checked all them images of mine with photo forensics, and I found out I made a mistake. So then what I did my testing the moon, where I measured the moon properly when it was at apogee and perigee, and I corrected the issue. You know what I mean? So I'm always open to question, and I've always, like I say, tried to correct any errors I've made in the past.
Well, what I want to say that you are right about something, but you still don't know what is that you're right about. That I just would love to talk to you, but not a hangout, because it's confusing. I just want to show you papers and things like that.
Yeah, that'd be cool. Like I say, I am quite busy, but definitely, you know what I mean. If you want to arrange your time sometime around my work and that, then yes, I'll be available. It's just it's very, very difficult to, you know what I mean, to squeeze time in, because like I said, with work at the moment, I've got to keep on top of things. You know what I mean. I can't be sacrificing sleep when I need to be on the ball at work as well. So it is quite difficult at this moment in time. But yes, I'll definitely. But have you got anything you want to mention now, or anything what you found out, or?
Yes, in short, you say that the moon, when it's in perigee, it should be the fastest, as Kepler says.
Yeah, according to Kepler's law, yeah.
Yeah. So when the moon is at perigee or at apogee, that is when it's at its lowest point or highest point.
Yes. Well. What is interesting from a globe perspective, when the moon is at perigee, although it would speed up in the cycle, it would appear to slow down in the night sky, if you know what I mean. And then when it's at apogee, set against the stars, it would appear to speed up. You know what I mean? It's like the opposite. So you wouldn't notice a speed up at perigee. From a globe perspective, it would actually appear to slow down relative to the stars, and then speed up at apogee, which is like backward. I know it's backwards, but that's how it would be on a globe on a turning on its axis.
The problem is that when the moon is at the apogee or perigee, it is not at the highest or lowest. That's what I found. I mean, if you look at the distance in time and date, you'll find it speeding up at the closest distance. But that distance, that's not either apogee or perigee. So that's strange. I mean,
yeah, like I say, there is a lot of things you find out about the moon. You know what I mean? Like I say, it's the only thing I know for sure is that it does measure bigger at perigee, and it does measure smaller at apogee, because I've measured it on at least 10 times now. You know what I mean? I think I've caught about 5 at apogee last year, and I've caught quite a few. And the last one I caught was on, I think it was the 22nd of December last year. You know what I mean? When it was at perigee. So I've got quite a lot of observations to test it. And one thing I'm 100% sure that there is an increase in size, and it's quite a big increase as well. I think I measured 11% from its smallest size at apogee to its biggest size at perigee. Now, if you was thinking about putting a model together, making a flat earth model, you have to take these things into account. You know what I mean? You can't just ignore them and just expect the sun and moon to be circling on over a map and it's not doing anything else apart from circling it, because there's other motions taking place. Yeah. So we have to account for all them.
Yeah.
And what I've tried to do is try to put the information out there and say, you know what? Yeah, the sun during winter measures bigger, and the moon, when it is at apogee, it measures smaller. So we have to account for this when we're putting these models together. We can't just stick two objects above a map and say, yeah, that's a working model. So this is what I'm trying to do. I'm trying to get all the information, you know what I mean, all the information from a flat earth perspective and put it out there, and hopefully other people pick it up as well. Which, like I say, you've obviously seen a lot of the stuff I've been doing and you're like picking up on it. And I know Richard's, Mr. Thrive and Survive, he's done the same. So that's what I'm trying to do. You know what I mean? Just trying to put the information out there, and I'm doing everything I do. I document, and I keep it all on my computer as well. So I've got every reading I've ever taken, I've got on the computer. Every measurement I've got, you know what I mean? And I've obviously got all my videos, what I've made.
Yeah, I've seen your recent video about the sun from your place and from America. It was beautiful. Yeah, thank you.
Yeah, that was that. Like I say, that was just something. Just me and Jenna Fredo got our heads together because she seen my moon race video. She says, "Have you ever thought about doing this with the sun?" Now we all know that the sun, to get from tropic to tropic, takes 6 months, so it's a bit of a long haul. You know what I mean? With the moon, you have to wait 2 weeks. With the sun, you have to wait 6 months. But we have got all the footage from the summer solstice, the equinox, and the winter solstice. But because I've got so much going on, it literally took me 6 months to put that video out, because I set the bar quite high, you know what I mean? And I was learning new things on the video software. And then when I was leaving it for like 2 or 3 weeks and going back, I was having to relearn what I'd done, you know what I mean? I'd done these like fancy overlays.
I know,
and
exactly.
And I couldn't remember how to do them. So I'm watching like guides and how I actually did it, you know what I mean? So it's, but like I say, for what me and Jenna did with the information that we had was so difficult, because we're both using different cameras. You know what I mean? It's when you're using different cameras with different focal lengths, it's very, very difficult to match up. And I could match mine to Jenna's, and she could match hers with mine, but she could only do it at 1400 millimeter focal length, where I could do it at 1440. You know what I mean? That's as close as we could get. But it was interesting because all the data literally matched up. You know what I mean? What we was observing is what we was actually recording, and that's when I got the chance to obviously measure the actual sun from the summer solstice, from the equinox, and to the winter. So I've got measurements all at solar noon, and there is quite a significant change in size, which is quite strange, even from a flat Earth perspective, because for the moon, for the sun to be bigger, you would think, you know, like when you get a supermoon, it's bigger and it's brighter. Well, you would expect that with the sun, but clearly it's bigger, but you know what I mean? You're not getting that heat from it like you would get when it's more direct in summer. So it is probably more of an angle problem, you know, with the sun. It must be when the sun's more direct on you, you get a lot more heat, even though it's bigger, but the angle's slightly different. It's not direct on you. A bit like the globe model, I would suggest, but it's the same kind of thing. You're not getting the sun direct on you, so you're not getting that heat from it, even though it measures bigger, which is very, very strange.
Overhead.
Yeah, exactly. You know what I mean? It's not direct onto you. But like I say, we got quite a lot of information from that, because, like I say, the time the sun travels from one point to another from a specific time, we measured how many degrees it actually traveled in that time, you know what I mean? And there is a difference there. And obviously when the sun rises, it rises further north for me than it did with Jenna, which is quite interesting as well. And another thing, what I did notice when we were shooting this during the equinox, when we captured the moon does some ridiculously huge jumps north, and I'm talking like mega jumps north, because normally the moon will rise like on average 50 minutes after the sun each day, but during the equinox, yeah, that time comes down to less than to like, I mean, seriously comes down. It's like it's rising a hell of a lot earlier than it is, because it's doing these massive jumps north, you know what I mean? So it's appearing there earlier. And if you just look at it on like time and date or Mooncalc, and just look how big them leaps the moon does during that the equinox, the autumn equinox, you'll see that it really is like unbelievable to see how big them leaps are, you know what I mean? Especially in the northern. Say again?
You mean day to day, like from
yeah,
one day
to day, yeah, just over the equinox period, just for about 4 days, it does these massive jumps north, and you know what I mean, it's rising a hell of a lot earlier because of them.
Changes
these big...
the ecliptic, basically, right?
Yeah.
Or what they call that ecliptic, I guess.
Yeah, but it's interesting to see, because like I say, you expect it to rise at a certain time, and the further north you go, it rises earlier, you know what I mean? It's interesting.
And it's kind of taking more of an angle across the sky if it's the more north it is. Yeah,
like I say, there is a lot going on out there that we just ain't got a clue about, you know what I mean? So it's you just seem to, the rabbit hole gets deeper and deeper and deeper, and you think you're learning something about one thing, and you end up like not knowing anything about it, and you spent like 6 months looking into it, you know what I mean? It's it can be quite frustrating at times, and it can be very mind-boggling.
Yeah, for sure.
The moon subject is very complicated if you want to study it from the globe perspective, because for one thing, the orbit of the moon, the orbit itself is rotating every 18 years or something. That's what the globe model says.
There is an 18-year cycle to the moon.
Yeah.
We call it a Saros cycle. So basically, if you take the eclipse what we've just had now, and you went 18 years, 11 days and 8 hours, you will find the exact same eclipse takes place, you know what I mean? That'll fit into one Saros, and every eclipse will follow that pattern. And what they do, they build up a series of what you call Saros cycles, which was discovered by the Babylonians 3,000 years ago. You know what I mean? They was predicting eclipses back then. There was no technology like they have today. You know what I mean? They just literally counted the days from one eclipse to the next. And because they had the data from the previous eclipse, they just know that the eclipse happened like clockwork. You know what I mean? Like Christmas Day and your birthday. So all it is, once you know that length, which is always 18 years, 11 days and 8 hours, then you can predict any eclipse.
Yeah. I gotta look into this. This sounds very interesting.
Yeah, the Saros cycle, like I say, it was discovered by the Babylonians like 3,000. I think it was like 3,000 years ago. And when you start looking into it, there's, like I say, I think there was probably out by a few hours, but they could literally predict every single eclipse.
Like Halley's Comet, right? Every 75 years or something, shy of that or something.
Yeah, same as that. It's these astronomical events happen like clockwork. You know what I mean? All these comets.
The interesting thing about that too is that it would take probably a few generations to realize something every 75 years. You know?
Yes, and what's interesting is that probably all that documentation and all that information is probably what the Vatican have got in their dungeons. You know what I mean?
Yeah, probably.
They've probably got all the. They've probably got all the charts and all the tables and all you need, because I've got the Adventures of Cosmas based on the Christian topography. It's a great book, and there's a big piece in the beginning of the book thanking the Vatican for access to their dungeons, basically, so he can put the book together. You know what I mean? So what they've got down there is they've got a hell of a lot of the original, probably not the original books as such, but probably the old tablets. What there was, all the information was gathered on in them days, because there is quite a lot of information. And I don't know if you've read the Christian topography, but it's definitely worth a read. What I like about the Christian topography as well, it completely destroys the flat Earth psyop. You know what I mean? Because this book is written in the 6th century, and they've still it's still like probably the most documented book of its time. And Cosmos was an avid flat earther, should I say, for a Christian monk, which is quite interesting.
Is that rare?
Because
like for that time, I mean, as far
for
as
that
like
time, yeah, because obviously they were still pushing the ball then.
yeah,
but you got to remember there was no force of gravity then. So the question he's asking is, how the hell is somebody opposite me on the ball sticking to it? You know what I mean? That was his question.
Reality.
Because there is no gravity or any force at all during that time, and it's if you haven't read the book, it's free to read online. Just put in Christian topography, and it's on that sacred text, and it's definitely worth a read. And he's even got his own model, which is a bit like a tabernacle. So it's interesting. Look him up.
I'll look that up.
We don't really know how advanced they were in the past anymore, do we?
Well,
probably a lot more.
All you have to do is read Ptolemy's try and read Ptolemy's Almagest, then you'll see just how advanced they are when they, you know what I mean? When you've got Hipparchus, who created trigonometry, you know what I mean? All the surveyor stuff we do today was created in the 2nd century BC by Hipparchus, you know what I mean? So all these technologies and all these scientific mathematic ways they use today weren't created by NASA or any other scientists. It was created by the ancients years before. And if you look at Hipparchus's epicycle, which is a way of explaining how the geocentric model worked, you know, basically by a visual, it's quite interesting, because it's like a circle within a circle. But what they did in them days to actually show eccentricity in a celestial object, they use what you call an equant, and it's like a slightly off center circle, and that's what causes apogee and perigee with the moon. And you know what I mean? So it is interesting, because you think, oh yeah, the apogee and perigee was only created on the back of Kepler's law of planetary motion, you know what I mean? But it goes back way like 2,000 or 3,000 years before them. They was predicting eclipses, and they was documenting all the information. And like I say, I bought Ptolemy's Almagest thinking I would get stuck into it, and I think I'm about on page 8. It's just like literally impossible to read, because it's so advanced, you know what I mean? Especially, it's too advanced for me. And like I say, I have tried to read it a couple of times, and it is a really tough read. It's all geometry and stuff like that, so it is tough.
You're too advanced for me, Dave.
I wouldn't say, like I say, everything I've learned has been in the last 3 years.
Yeah, but I've kind of watched this stuff. Actually, in a lot of people, there's a lot of people like you that have been doing the exact, you know, very similar. You've come into knowledge that you're building, like, and it's real knowledge. It's you're doing it on your own, not with school books.
Yeah, like I said, what I thought is the best place would be to start is where the ancients started, where they didn't have all this fancy equipment. You know what I mean? I haven't got no fancy equipment, so I have to adapt to what equipment I have got. You know what I mean? I'm using cameras, phone apps for compasses. You know what I mean? Or a compass reading.
Don't you, Dave? You like to have stuff where you can sort of check it with that, check it with that, check it with this. Do your own things.
Like I say, people say you can't measure the speed of the moon by measuring the meridian passing, but you can measure the stars by measuring the meridian passing. You can measure the sun by measuring the meridian passing. Yeah, you can measure any of the so-called planets by when it crosses your meridian. So, but they say you can't do it with the moon. which doesn't make sense to me. Yeah, because that meridian passing time, you're taking the moon at its zenith, and all you're doing is measuring that time frame from one point to the next, and you're just measuring that gap, and you just document it on a daily basis throughout the year. You know what I mean? And then it builds up like, you know what I mean, like a graph, which doesn't fit the heliocentric model, because the moon will speed up and slow down, then stay at relatively the same speed, and speed up, slow down, you know, when you look at it in a graph. Whereas in Kepler's law, what they're saying is that it'll speed up towards its point of apogee, then slow down, but it'd be like a gradual increase, you know what I mean? Probably not even noticeable. But like I say, the methods I've used for measuring the moon are crude, but they were crude in the olden days or the ancient times, but it was still effective. If you look at Ptolemy's model, you know what I mean? It's still a very accurate model, even though it was based on a geocentric globe. So.
Yes, Dave.
I got a cat giving me trouble, so I might check out for just a half second.
Is that your cat, Joe? Is it the one what not very friendly?
Oh yeah, well, I could bring her in here and show you. I'll go grab her and I'll bring her in here and show you. She's nice, but she's like kind of wild. I'll be right back.
All right.
I was messaging Rich to see whether Rich, Mr. Five and Survival, will come on. He's out at the moment, but he did say to say hello to Crow, Dave, Joe, everybody. I'm hoping he might join us for a bit, but he's just out.
Yes. So
yeah, I was hoping Yeah, go ahead, Dave.
I was just going to say, Crow, if you want to team up with me and start like going through some stuff, you know what I mean? I can show you how I put all my readings together into my spreadsheets and all that. And just what I wanted to say is, like, when you do look at how these astronomers from the time of Kepler or whatever, how they measured some of the distances to the moon, or how they measured the distance to the sun, you know what I mean? It is really laughable, because they use triangulations and they use a presumed Earth orbit as a baseline, 190 million mile baseline for triangulation, which is absolute nonsense. Yeah, because that's presuming that the Earth is moving in its orbit.
I got to interrupt because my cat's she gets kind of mad when I try to hold her.
It's huge.
Do you hear her?
I can see her, yeah.
Don't hold. Let me go. Push me down.
Yeah. I just gave her catnip, so she's a little high.
Sorry, carry on, Dave. Sorry.
Yep. Sorry, Dave.
Yeah, but like I say, when you look at all this, like all these ancient astronomers, like Hipparchus, when he created triangulation and he tried to measure the distance of the stars, and he couldn't get a baseline long enough, so he presumed the stars were infinitely fixed. Now, that was the biggest blunder, or the biggest problem from the very, very beginning of astronomy, and every bit of astronomy from that point has been built up on that mistake. You know what I mean? So nobody ever picked up on the mistake what Hipparchus made, even though he probably like a genius for his time. Yeah, his triangulation blunder has been ignored all the way through astronomy, and every single bit of astronomy has been built on the back of that. So when
but I think until now they cannot measure the star's distance by parallax. Until now, I'm not sure.
It's, yeah, I mean, like I say, the actual, I think it was Tycho Brahe who says the measuring parallax is only in the minds of the observer. Yeah, you know what I mean? It's nothing to do that. There is no, you can't measure something like that. The distances, what they're giving you, and the measurements what they're giving you are so minute. You know what I mean? We know that, like, if the stars were infinitely fixed at an infinite distance, Polaris would be above your head all the time. You know what I mean? Not just some of the time. it wouldn't change its angle towards you because it would be infinitely fixed. Now, when they say when you do a time lapse with the star trail, now I found a 12-hour time lapse, and in that time the Earth would have moved in its orbit like 32,000 miles or whatever. You know what I mean? But there's no detection of that at all. Yeah, you've got the actual obviously motion of the stars, but you've got no actually motion across along the ecliptic. So you know what I mean? It doesn't make sense. But like I say, if I travel 100 miles south, Polaris will change its angle to me by a degree. So what they're saying is that the Earth can move 32,000 miles, yeah, and not change, yeah. But I can,
and then curvature comes into that for them too, right? Because
yeah, that's the thing.
Yeah, changing changing your position or your angle in space. That's the.
Well, if you've watched the Phuket Word's latest video where he measured the angle to Polaris in degrees, and what he found is that when you measure it from steps of 10 degrees latitude, yeah, that point from Polaris makes a curve, yeah, and that curve works out exactly the same as the Earth curvature, but the opposite way around, if you know what I mean. So it's, yeah, what if it was on a flat plane, yeah, the stars could never be infinite because Polaris is dropping as you move away from it, you know what I mean, on the horizon. Now on a globe, what they do with that is they say, yeah, because that's the curvature of the Earth. So it's one of these things where you say, is the Earth stationary or is it moving? You know what I mean? It's that question what Einstein asked when he says, if you're on a train, yeah, even though it looks like the scenery's the train is moving and the scenery is like standing still, it could be you standing still, but the scenery is actually moving, even though the wheels are going around on the train. You know what I mean? That's what question he puts to the observer, and he's basically telling you to deceive your senses by that, because if we go by our senses tell us that nothing's moving. You know what I mean? If we all went by as God-given senses, it clearly tells us that nothing is in motion. You know what I mean? There's no detectable motion of any kind.
Yeah.
That's kind of like the video that Karen put a few weeks ago of a pilot pouring water while he's upside down.
Yes, that's quite interesting, isn't it? It's quite cool.
Yeah, and his water didn't move at all, did it?
Yeah, he was just pouring the water.
Centrifugal force is keeping that water in the glass. You know what I mean? He's not. He's obviously he's doing it. He's doing a like a, you know what I mean, like a circle kind of thing. Like yep, that. Joe's got it.
Yeah. I got Joe.
Yeah, it's not rocket science.
You know, like the distance to the sun is the same thing. Like the curvature comes into that too. So it's all, we've proved that there's no curvature. The world doesn't hear us, but we've proved it several times that water doesn't curve, right? What I'm saying is, if we did that, their stick in the well or whatever, the stick shadow experiment, do that on water, and your sun will be a lot closer, won't it?
Well, that experiment is so easy to do. You know what I mean? You can do it in your own living room. If you get two lighters and you put one perpendicular to your light, then you move one 3 foot to the side. The one under light won't cast a shadow, but the one 3 foot will cast a shadow. You know what I mean? That's on a perfect level floor, only 3 feet apart.
Now move it around in a circle, and you'll get what a shadow does every day.
Exactly.
Yep. And when it's far away, it'll be dark over here.
Exactly, because it only lights up a small portion at a time.
Yeah, and then here's the thing too. Nathan Thompson said this on a video, like when he was out on the street. What do they call it? Flat smacking. And he said, this street light right here, you won't be able to see it from the other end of town. It's not going to light up the other end of town. It's only going to light up just this right here. So just make that a larger scale, and there's Earth, you know?
Exactly.
And then the heat from the sun, that's another proof, because right now right here, I think it's probably about 10, 15 degrees where I'm at. And I mean, temperature wise, and the sun is like really low and really far. all day long in the winter. Then in the summer, it's really close and really hot, like right above my head, and I'm sweating and it's hot. That's because it's closer. This should be common sense.
But can I
Exactly.
say something, Joe, listen, we're talking to people in Australia. For him to have hot weather, the sun's got to be low in the sky. In the summer, it comes low for them to get hot days and long nights. But it's the complete opposite for us in the north.
It's the opposite. Okay.
Yeah, if you look at it, it's, you know what I mean. What I did for an example.
So it's crazy, isn't it? It's crazy, isn't it? For him to have it hot, for us to have it hot, it has to be high in the sky, and for him to have it hot, it has to be low in the sky. Yeah,
but you know, if you look at SunCalc and you take the UK for example, and what I did, I found the farthest town south, which is Ushuaia in southern Argentina, which is on the exact opposite latitude we are. Yeah, during their summer solstice, they have the exact same rise times. The sun's visible for the same amount of time, and they have the same set times as we have in our summer solstice. You know what I mean? It's literally exactly, and I've got a picture of it where you can see it, and the rise and set times are nearly identical within minutes. You know what I mean? It's so what's happening here is also happening in the south. So.
But he was showing us that the arc in the sky of the sun, in the sun and the wind, summer and the winter, isn't very big. You know, like for me, it goes over my house, and you know, I feel it's got like it's a length. He just says it goes up and down.
Yes, because he's closer to the tropics. You see, what you'll find is when somebody is in like northern Australia. When I went to Fuerteventura, all the sun and the moon did was go over my head. It looked like they're doing a perfectly straight line. Yeah. There's very little art there from at all, and also what you do, you'll see the moon do a 180 degrees flip when it's high on the Tropic of Cancer. Because as the moon passes over your meridian, you have to turn 180 degrees to keep on following it. Yeah. So what happens is, if you've got a camera on it, and it's rising from the east, as it passes over your meridian, you have to spin around physically and watch it set to the west. And the moon will do a 180 degrees flip as it passes over your meridian. But it only happens when it's high on the Tropic of Cancer, when you're in places like Fuerteventura, which you showed your friend in Mexico who did it when it's on the other tropics. You know what I mean? So.
Yeah, you sent me the little video, didn't you, when you saw it?
Yeah, I showed you how it flips.
Yeah.
But that's just due to perspective. People say the moon's rolling in the sky, but it's not. It's just the observer's perspective, what they call field rotation. Yeah, it's literally the observer has to turn to keep following the moon. So the moon doesn't actually turn in the sky. It's the observer what has to turn to keep following the moon, if you know what I mean. We don't see that a lot here. Go on, sorry.
Karen, Joe, and Dave, I'm thankful for having me tonight. I just have to go for now. And I hope that, Dave, I've sent you a message and Hangouts. I just contact me whenever you have spare time.
I will do. No worries.
Nice to meet you.
Okay,
nice to meet you, Crow.
Crowxe, thank you.
Take care.
Thank you, Karen.
Hi,
say hi to Rich.
I will. He said hello to you.
Yeah, thank you. Bye-bye.
Bye-bye, darling.
Bye-bye.
Yeah, so, it's always good because I'm not sure where Crow stands, but at least he's a really nice guy and he comes on our Hangouts sometimes, so that's good, isn't it? You know, whether he's a flat earther or a globe person. But I think what it is the globe doesn't add up to him either, so that's good, isn't it? Because it doesn't add up anyway.
I think actually, it's you just said it just perfect, Karen. Is when someone starts looking, and they're going to run into people like us that have been looking for a long time, and they're going to say, well, the stuff they're saying is, you know, some of it's legitimate stuff that isn't working out on this thing behind me. I think it's going to be obvious one day, but I think it's still going to be a long time until that, I guess, until people accept it, but I don't know.
Well, I don't know if you saw my video. I did make a a reply video to Slyman Dan in regard, because he made one of his videos he made recently was about me and Rich.
Yeah, I think I saw yours, but I don't think I saw the whole thing.
Yeah, well, I just made a quick video, like, you know what I mean, asking him the questions and telling him to show me how the proper way is to measure it. Because what he does, he likes to talk the talk, but he doesn't like to walk the walk. You know what I mean? He likes to just believe what everybody's told him out of the textbooks. Yeah, and he won't even question none of it. You know what I mean? Now science is about questioning everything. You know what I mean?
He just wants to make fun of people.
like I say,
he wants to just act superior.
And not only that, I think he's in it for the money. You know what I mean? Because you know, on YouTube, his subscribers has jumped up. I mean, massively over the last 6 months.
All of his videos are like flat Earth, aren't they? I mean,
yeah, he does Flat Earth Friday, then he does Tinfoil Tuesday.
Okay.
So
Mike Helmick does Testimony Tuesday. That's probably better to listen to.
Yes, it probably is. I haven't seen Mike for a while. Has he been on the show, Karen? Or
he's coming on? He's coming on. I'm trying to arrange. I think what it was is I'm gonna do it with Flat Earth Brothers and also Bling Bling and maybe her son. He'd really like to have a hangout with her son.
Yeah. While it's fresh in my mind, what I wanted to talk about is, you know, like people have been observing the moon from the UK and Australia. Now, this is an interesting. This is because what they said, what the globularists will tell you is that it's possible on a globe if you've got an observer in the UK and you've got the moon equidistant between you. You know what I mean? On a ball, you both would be able to observe the moon at the same time. Now, interestingly, when the moon is low on the Tropic of Capricorn, from only 69 degrees north, it doesn't rise. So how can it be visible from UK to Australia when it's equidistant, but you never see it rise from only 69 degrees when it's just on the Tropic of Capricorn? So you can't have it best of both ways. On a ball, you should be able to see it from both directions. You know what I mean? Because it's a similar distance, yet it never rises at 69 degrees north when it's on the Tropic of Capricorn. And the moon is only supposed to be inclined by 5 degrees as well. So it's a double-ended sword where you can't have it best of both worlds. Yeah,
it's a bit of a shame, isn't it, that all those observatories, which are, you know, especially some of them are quite high in the sky, aren't they, in some places, but those great big observatories aren't doing this for you.
Yeah, like I said, I mean, I'm not being funny, but I've never actually seen a decent picture through an observatory.
I haven't either. I gotta say, here's that footage that I took. I found it. If you can find this kind of footage, I'm just saying, I challenge anyone to show me footage of an eclipse or something with some detail. This was just my little camera out by some lake with what I'm saying is, observatories, they give you images. I want video. It's 2019.
That's amazing. That's like I said, the first time I've seen that.
See how the light, how slow it's moving? You can see the light is climbing down slowly. And now the prominence or whatever is gone. I got some good footage of it that day. It was awesome. I'm like in the way.
Yeah, that is brilliant.
Isn't that great right there?
Yeah.
But yeah, so I found it, so I figured I'd show it to you.
Well, where you've got that light seeping through there, when I caught the crescent moon the other morning or other evening, what I saw is where the lit part was, there was like a big gap, and then there was like another bit of a lit part. You know what I mean? It was like the light was very selective from the distance to the sun. You know what I mean? 90 odd million miles away, and to be that precise and that selective from that distance it's
not
uncanny.
really moving, is it? Whatever that isn't really moving in the film. It's not like that's wobbling and moving around. It's like it's stuck there, isn't it? I was trying to find this. Sorry, this is a time lapse of that eclipse that I took. There were some clouds, but perfect timing, because when it was like full totality or whatever, the clouds kind of disappeared.
right there. So that was nice.
Yeah,
And it
that's
just sped
brilliant.
up.
That is awesome. That is that.
I like that this software that I have. I can make like 50 little movie screens on here if I want, as many as I want. It's pretty cool. I can just
And
keep adding.
that's another reason why I want to get the camera made full spectrum, because then you can have a look at the sun through a H alpha filter and see what's really going on. You know what I mean?
That would be awesome. That's what I really want to do that with one of my cameras. There we go. There's a spinning ball for you of water.
That's cool.
I love it.
I don't know who made this, but it's great. I thought it was great, so I stole it.
Yeah, I seen that a few weeks back. It's cool. But yeah, that footage you got there is amazing. It's like I say, it's better than what NASA showed us on the day. You know what I mean?
Yeah. Well, that was honestly, I put a video up. It was just a re-upload of Polaris, and I titled it something like "Challenge to NASA" or something like that. I want to see some video with their equipment, because this is my equipment just stuck up in the air from the ground. And what I'm saying is they should have really cool footage from the ISS. And then you see what we get from the ISS. We get the big ball Earth with this big, huge shadow, kind of just, it's not really there.
Or a black screen.
Yeah. Oh yeah. You know what? I'm going to work on something while we're talking here. I'm going to try to find that. I forgot about that shadow. I want to show you guys that shadow too. I'll see if I can get it.
That is great. It's uncanny. That is.
Then, Dave, because it doesn't really move, does it? When it comes into view, it just is still.
Yeah. I don't know, to tell you the truth. You know what I mean? There's something supernatural happening on an eclipse. It's not something that we can really try and explain. I don't think you can explain anyway.
Whether it moves actually to start with, but it just doesn't move, does it? It doesn't grow or move across the screen or the camera. It just is fixed.
Yeah, I think like when you're trying to model something, it doesn't work. You know what I mean? It doesn't fit. You know. And so
like triangulating it, like if here's what I think it's celestial. So I don't even think it's like the same as our physical world necessarily. I'm not saying it's not physical or whatever. I don't really understand it, but it's like you said, it's supernatural what's happening.
Yeah, it's there's something supernatural happening out there which can't be explained by science.
Yeah,
you know what I mean? It's that's what conclusion I come to, because
and that's I think what we're supposed to come to, you know.
Did you find anybody else that had caught it, Joe, like you did?
I did. There's some good footage kind of all across the path, the totality there was people getting good footage, but I didn't see anyone that zoomed in like I did, and I think it's because most people want to get like a continuous shot where their camera's not moving all over. And so I kind of jeopardized, and I was like, I'm just zooming in on that because that looks cool, you know?
Yeah, it is pretty damn cool. Yeah, you can see it down the bottom end as well, can't you?
I'm looking for this other one here now.
Have you caught anything like that, Dave?
No, because I've never filmed a solar eclipse, so
let's see, do I have it?
I'm still struggling. I've missed 4 lunar eclipses.
Oh, no, because of the UK's cloud.
Yeah, my first attempt was the one in September 2016, I believe, which was like a partial eclipse, and nothing happened that night. Nothing happened at all. I took 100 and some shots.
Really?
I'm thinking when I stitched them all together, I thought I'd probably see it. You know what I mean? At the time, I was just snapping away 1 shot a minute. I'm thinking, right, when I put all these together, I'm going to see like a faint shadow go across the moon, but nothing happened.
No,
Nothing whatsoever. It was a partial one where it apparently just entered the penumbra. You know what I mean? It didn't actually enter the umbra part of the shadow. So it was like literally a partial
like a percentage
eclipse,
of one, like a percentage of like a small.
You didn't see the actual shadow or anything like that. It was just like a partial one, but it was rubbish. So that's the only one I caught. And then obviously we had another one after that where I literally was outside live, and I just filmed the clouds for 3 hours. and it was teasing me. It kept coming out and going back in. That was a partial eclipse. Then we had the full one in July 2018, which I was ready for, and my friend came down from Liverpool, and we got ready to shoot it, and it was overcast for everybody in the UK that day. I don't think anybody got it in the UK that day. And then obviously we just had this one at the beginning of 2019, and it was looking good from 4, 5, 6, 7, 8 right up to 2 o'clock in the morning. Then boom, it started raining. I was gutted.
Oh.
And when I looked on the radar, there was just like a strip of dark cloud over the the middle of the UK where I was. People in Sunderland or above there, they were probably loving it because it was clear there, and I know that a few people in Scotland caught it and Liverpool. So it just happens to be in the Midlands where it's always cloudy. You know what I mean? I couldn't be in a worse part of the country, really, to try and make observations.
You know what, Dave? I'm just thinking that actually the UK is a really good place to actually take pictures of the stars and that. A lot happens right over our heads. In other countries, it's over there or it's stretched. And I'm wondering whether that's another reason why they have to make us cloudy so that we can't capture all this stuff. Because the UK might be able to prove really what's going on if we had enough nights without.
The problem is we're a small island and we're surrounded by water. Yeah. So what we do, we get that warmth from the ocean, what comes from the Gulf Stream, and that's what causes. That's why in the UK it's not really cold in winter. You know what I mean? Because it keeps it a bit warm, and that's why it's always cloudy around here as well. Yeah. If you go to
Here's a loop of that, the shadow of that August 2017 one. If you look at the edges of this shadow, the clouds aren't moving very far till the other side of the shadow comes. That was the eclipse. That was full totality right there. So what I'm saying is that
play it again so people can see the shadow. It's a shadow.
Yeah, I'm just looping. It's just a loop going, playing it over and over again. So here it starts, and you can see how crisp that edge of the shadow is. Well, if you look at NASA's footage from ISS or from that Epic satellite, it doesn't match. Does not match at all. It's like a washed out, faded, shadow that doesn't have distinct edges. Well, this one that I looked at above my head had very distinct edges,
Yeah, it is a sharp edge. I noticed that. And I thought to myself, how can that be that sharp?
So that actually, the shadow there is actually, what was it? 2.5 minutes or something like that. I think totality was. I was in Nebraska, Lincoln, Nebraska, just south of Lincoln, Nebraska. But so yeah, I just wanted to show you guys that because to me,
I put that out on Sun and Moon, haven't I? I
bet you have. Yeah, I think you have. So that right there is the same footage as this behind me. Not the old ball Earth there. I'm gonna get rid of that. But yeah, these are the same footage right here, or the same eclipse. One camera, we're at P900, and then the shadow is the GoPro sitting on my truck. So
yeah, that is like
to actually see it, but not see it because you've only got it as a shadow. But even as a shadow, you can see the sun change, goes different, the sky goes different,
yeah.
Everything is different.
Yeah, did you see the
going over?
Did you see the stars as well, Joe, when it was totality?
Yeah, I have other footage that I took with Sony Handycam, where you could see. I'm not sure, was it Regulus maybe that was really close to the moon?
I know Venus was close by as well.
Maybe it was Venus that I saw, but I did for sure see one star, and it was, I don't remember exactly. I think it was maybe like when I was looking up, I think it was like down to the left maybe, but I'm not sure.
Interestingly, they proved Einstein's theory was correct. When it says that all light bends, because what they did, they took it on a solar eclipse, and they expected the stars to be closer to the actual sun during totality, but they actually went further away. It did opposite what it was supposed to do. You know what I mean? The stars actually appeared further away in the actual sky than where they would be on a normal night sky. So it completely destroyed Einstein's theory of general relativity.
Dave, you did that. You destroyed it. I'm just kidding.
Yeah, I think I'm proud of both of you. You've done such great work. even Joe, you know, he does a lot of photography and he takes his telescope out and stuff like that. So
yeah, Joe does some great stuff. Like I say, I love all the ISS stuff. It's,
Yeah, I'm
it's
gonna
fun.
actually work on that video now. Now that you mentioned the ISS and the footage of it, because I get decent footage with the P1000, but I think I might have even gotten better footage with the P900. So I don't know, but
yeah, Joe's my astronaut hero.
Yeah,
Yeah.
just on the subject, Joe. They reckon that the P1000 is a lot better for shooting like stars and stuff and that, because you can actually in like video mode, you can actually do like a manual video mode, can't you? So you can actually change the settings as you're doing it, where it was quite limited on the 900, weren't it?
Yes, definitely. The P1000. My favorite part about it is that it's like as big as a cannon. You put it on your shoulder to shoot. I'm just kidding, but I love it's got. I don't have it right here. I guess it's up in the other room, but I love the focus on it. It has that big ring on the outside that you can hold it really well and get the focus without.
Yeah, that's what I like about it.
P900, I had trouble getting, you know, like if you're trying to keep something in the viewfinder and you're zoomed way in, you're trying to focus, it was really difficult.
Can I just say something? Sandra, P900, she's just sent me a picture of, I think, obviously her Eclipse from the other day. And a lot of people were saying that it was a very dark red on the moon when they saw it.
Oh, yeah. I should probably, in the background, I've been.
Sandra!
Thanks, Sandra. Sandra was lucky, like I say, because when you looked at the radar, it was pretty clear up north. You know what I mean? Just in that Midlands bit where I was, where you just had that big black cloud straight through the centre, which was quite disappointing. Like, because like I say, I really wanted to catch this eclipse, and I was like ready for it. You know what I mean?
Yeah,
and
you were.
It was quite disappointing not to catch it. Like, and it's the typical British weather. Well, let me down again. But never mind.
There was a lot of footage, though.
Yeah, next one's in 2022, so I ain't got long to wait, really.
Mm-hmm.
Do you think
when are we going to see another?
Oh, go ahead. On purpose so that we can't see things? Because I'm pretty sure, because like I say, if the Big Dipper's going round my house, you know, everything's much more focused over our heads, whereas for Joe, it's much more stretched. And when you get over to Europe and a bit more north, it's all over there. You know, you're moving away from the centre bit. So we would be able to show a lot here.
And yeah, I like that. Where are you right now, Dave?
I'm in the what you call the East Midlands. It's literally in the centre of the UK. Okay, it's about 52 degrees north. So
okay, I think that this is. Let me just point something out that just came to my mind. It's really not related to what we're talking about necessarily, but it sort of is. The idea of you know, like Simon Dan or whatever, these type of people that they think they have an intellectual knowledge of something that they've never done or never looked at and never paid attention to until they wanted to debunk Dave or something, you know, or what Rich or whatever. But let me just point something out. It's 2019 and we have the best optics that have ever existed. So just keep all these things in mind when we're going to be ridiculing the people who are making observations and documenting them like Dave. Okay. Or, you know, I'm not as organized like Dave at all, but I have stuck my camera up in the sky a lot. But the also mixed with the idea that right now I'm talking from Minnesota, so North United States, and we're all around the world. You know what I mean? And we're communicating instantly. I can send Dave a picture any instant and he can do the same, and Karen. And what I'm getting at is, you don't think we can figure some of this stuff out better right now than we could before? Then you're just not paying attention. That's my piece.
There's never been a better time, you know what I mean? And the optics are just getting better and better, you know what I mean? Mm-hmm. It's scary to think what's going to come out next from either Nikon or Canon, you know what I mean?
It'll be the P2300.
Yeah. Yeah, 250 times zoom.
Yeah. Pretty soon you just be on a globe. You'll be looking right at the back of yourself. That's logical, right? Yeah. I'm just kidding.
Yeah, look at the amazing work that you two are doing. And of course, Dave, I know that Dave spends weeks and weeks and weeks and weeks and weeks doing some of these projects.
Yeah, and he puts
Yeah,
on work.
and hopefully, if
Don't appreciate when someone has a go at you, Dave, they just don't appreciate how long you've actually spent. You haven't just got your camera on, gone click, write it down, done, over. It's weeks. You do charts, you do figures. I mean, you even know, don't you, that some of the data comes out like a heartbeat. It's got a heartbeat wave on it.
yeah, well, what the problem is, you see, I'm looking at the doing all my research from a flat Earth perspective. You know what I mean? You can't do it from the globe Earth perspective because there's no measurable curvature. You know what I mean? So you have to do it from another perspective, and so I have to try and do all my research from a flat Earth perspective. You know what I mean? A lot of the research I've done doesn't really fit in with the like basic flat Earth model. You know what I mean? To me, that the flat Earth, the circle model, yeah, is completely wrong. You know what I mean? And it's a good representation of the flat Earth, but it's far from reality.
Yeah, it's
You know what I
just
mean?
an idea. It's an idea of that, you know, our compasses might work that way or like generally that way or something. But when it comes to mapping the Earth or modeling the Earth,
Yeah,
that's God's job. I mean, think about it. That's, you know,
that's when it becomes supernatural and you start banging your head against a brick wall. You know what I mean?
We can't comprehend anything more than our eyes and our ears at once can do. I mean, yes, we can put two people together, Dave over there, me over here, and we can get, you know, other information from that, but we can do that better now than we ever have. So, and we are. So
yeah,
Earth is flat.
and that's the thing, you see, where, you know what I mean, we are actually questioning science, whereas before it never got questioned. You know what I mean?
Exactly.
Regardless of these.
Oh, go ahead.
Regardless of these ridiculous theories that they come out with, all these astronomers, you know what I mean, Kepler's law of planetary motion, you know what I mean, you've got the aberration of light, you've got stellar parallax, you've got, you know what I mean, you've got all this triangulation and what have you, where they use the apparent Earth's orbit around the sun as a baseline, which is absolute nonsense. You know what I mean? And the globularists like Slyman Dan will just lap all this up. Then when you question it, yeah, they'll spend half an hour going through what you've produced with a fine-tooth pick to try and pick out little problems with it. Yeah, there's so many problems with the heliocentric model. What's staring them right in the face, and they're completely blind to it.
And then
you know what I mean? They're completely blind to it.
Yeah, and they don't pick all that to pieces, do they?
No, they'll start picking your character apart. Like, oh, look at his icon has sunglasses. I bet you he's not very smart. Like, you know what I'm saying? Like they take little jabs, and it's like, we're not talking about us.
Actually,
or you.
That, Joe. They're basically saying you do idiot.
Yeah.
Yeah. I mean, I've been told not to breed.
Yeah. We've all been told a lot of things.
It's a bit late then, isn't it? Because we have.
Yeah, because I've already got 3 kids, so yeah, it's a bit late.
Yeah, no, those kind of insults though, it's a little revealing of the subconscious position that these people are taking. It's a very defensive way to act, to be like, oh, well, I don't like the color of your shoes or whatever. When you're talking about some observations, or you're talking about you know, the shape of the Earth or any of these things, and it goes to the personal attacks, and you're like, what? I don't understand how it gets there, because we aren't talking about that. But
yeah,
okay.
I think it's because they've got no answer to it, have they? You know, you know, sometimes
it's something like, they've never thought about. They've never thought about it in the way that we're making them think about it, and it's not comfortable at first.
Programmed, aren't they? And that's what the program's like. It's quite nasty and narcissistic. Sorry, not every
you're right.
believes in the globe is all that, but that's the program that's in there. And I think they use all these channels just so they can be nasty.
Yeah, and not only that, I've watched a few films on Netflix recently, and usually watch the science fiction films, and every single one has got a man-made problem. You know what I mean? They say it's a man-made problem, like global warming, or, you know, in Interstellar, all the food sources drying up due to man-made problems. yeah, you know what I mean, all this like scaremongering tactics, you know what I mean, what keeps you on your toes, or should I say, and I'm sure you've seen all the fake news about this meteor is going to pass close to Earth, or it's going to hit Neptune, and you know what I mean, and make a hole as big as the Earth in Neptune. All this slight scaremongering they do all the time, you know what I mean. It's just nonsense. And I don't know if you've seen that meme where it shows you like a meteorite hitting the Earth, and you see somebody asleep in bed. You know what I mean? Like, that's us asleep in bed, because we know it's all nonsense. It just makes me laugh when you see all the programming, like, and yeah, or global warming, or whatever they want to say. You know what I mean? If it's not one thing, it's another. So it just cracks me up each time.
It's, you know, we can all like do the imaginary thing and take me when I was 5 and 6 years old or whatever, and then I'm 41. Here we are. So right next to me, and here, okay. So I got my little mini me next to me. Let's have a contest and see who can learn. Let's have a contest and see who can measure across the lake and see what kind of curve. Let's do some contests and see if the 5 or 6 year old Joe is as good as this Joe at figuring things out. That's, you know, just figuring anything out. How to drive a car, how to use a camera, how to check online and say hi to Dave on Facebook, whatever, you know. I think that a 5 and 6 year old child being told that this is the way, you're in your class and your teacher's telling you something, and that's really clashing with what you understand and observe and experience. And you look around the other kids and none of them are saying nothing. So they all get it. You know what I mean? They all get it. And I'm the only one that doesn't get it. So I'm just going to zip my lip, and that's how it is. Like, that's every kid. What they tell you, the earth is a ball, and it just doesn't. I'm sure for a 5 or 6 year old or 4-year-old, they've seen it so many times on TV and stuff that of course it's a ball by now. It's like a nasty trick.
Have you been following the Owen Benjamin on YouTube?
A little bit. I like seeing people honest with themselves. That's what I'd have to say about him. He's definitely he's not ready to accept a lie. And he's like very outspoken about that. I think that's cool.
Yeah, it was interesting when he was asking for globe Earth proofs.
Yeah. He's like,
I can't be a flat Earth person. I can't be a flat Earth person. You're saying, just give me a proof, and they're saying inertia.
Then David Weiss has some pretty cool short videos with him. Kind of, come talk to us. Oh,
yeah. Come talk to us, yeah. Because like I say, it just reminded me when I first stepped onto flat Earth, and I was like, you know what I mean? I was going through that mental challenge where you just can't accept it. You know what I mean? Your brain just won't accept it, and that's all the years of the programming. You know what I mean? And me previously,
it couldn't be. It couldn't be. It couldn't be. I said that for 3 days straight, and then on the 4th day, I was like, it is. Like I just, you know, it's like a battle that goes on in your head. You're like, no, this couldn't be. But once you realize that it is, it's not really whether someone's lying or not. It's obvious when you start to look, I think.
Yeah, and it just the Owen Benjamin that video what Karen B put together, it just reminded me, like you know what I mean, it like triggered something in my brain to like for that point in my awakening where I literally come to my senses and realized it, and it just reminded me so much of that, because I was saying that to myself, this can't be, you know what I mean, I'm going to find some proof. Yeah, it's not going to take me long, and you keep getting deeper and deeper and deeper, and you're like, where's the proof? You know what I mean? And all you seem to find on your journey is the lies, you know what I mean, and the deceit. It's there's just like I say, there's so limited proof out there, and once you get past all the lies and all the deception, it's not difficult to see, you know what I mean, where they use refraction indexes for curvature, you know what I mean, and they've got all this silly nonsense, like, and once you get past that, everything else seems to like fall in place. Does it make you a better person? I suppose it does make you a better person. You know what I mean? Because you're being more real to yourself as well. You know
And
what I mean?
honest.
And
I mean,
and honest.
because we can all.
You'd have missed. Look at that research and all those photographs and stars, and look what you'd have missed. We'd have missed Joe and on the ISS space station. We'd have missed being here.
Yeah. And we would miss the truth. You know, the truth is important.
Yeah, that's what I was just about to say. And the main thing is, you know what I mean? We're actually coming to terms with the true reality of where we actually live. You know what I mean? And
however intimidating that is at first. I remember, I mean, that, like you were just saying, that moment when you kind of, you know, that Owen Benjamin moment, that's going to be like a phrase now. But when that moment when you're like, I can't, it's not like when I was thinking about flat Earth, it was not even a ridiculed thing yet, because it just wasn't a thing or something, you know? So I didn't really think about being ridiculed. I more thought, people have to know this. And I thought people would accept, like, I thought they'd see it right away. But it's obviously like you were saying, the sun and moon and all this stuff above our heads is.
You'll never prove flat Earth by observing the sun and moon. What you will do, you will question the globe. You know what I mean?
Yes.
That's all you can do. And I've said this in an interview, because I did an interview with two students of philosophy of science from Manchester University. And that's what I tried to explain to them. You know what I mean? It's just one of these things where you have to see it for yourself. It's like when Morpheus says, you can't be told by the Matrix. You have to see it for yourself, and that's what you have to do. You have to see it with your own eyes. Yeah. Yep. And like I say, some people will accept it, and some people won't. And when Morpheus said that,
you two can stand here and say, I know, because you've been out with your cameras and seen.
Yeah, like I say, all I can do is question the globe with my observations. I can never prove that the Earth's flat by sticking my camera in the sky. It just won't. You just can't do it. You need to be doing the other experiments, like the experiment we're going to do with Dr. D. John on the 2nd of February, where he's actually he's doing refraction tests with lasers, not specifically measuring curvature with the lasers, but measuring
the light, or seeing what
the light actually does under different conditions and different changing weather patterns or whatever, you know what I mean, atmospheric conditions. So
like one of those really powerful lasers, like the.
Yes, and I'm thinking about getting one myself. I think they're like a 5-watt laser, aren't they? You know what I mean? They got like a 21-mile distance on them with.
I want one. That's cool.
Yeah, with minimum divergence as well. And I've seen them when they pop balloons with them as well, and light cigarettes up with them. So they are pretty powerful. Like so, but you can get one for about $300, which is pretty good. And I'm definitely thinking about getting one, because I think it, like I say, I want to expand into other areas. You know what I mean? I spent a lot of time observing the moon, and I just want to like try some other stuff as well. So,
well, I've looked at water. I'll tell you, water's flat. Like, water just sits flat everywhere on the Earth. That's what I say. And I live by a lake it's not a perfect circle or anything. It's kind of a weird shape, but where I go and look across there, like from a boat landing, where I can set my camera right down on the water. If the water's calm, I can, and I always just say 20 inches above the water, because I put it on a tripod. But I did one time, and I have a video on my channel. I did one time put it right, and I actually got my P900 wet, and I wasn't planning on doing that, but I was holding it right down by the water, and I went and zoomed across the lake, and isn't like the best video, but there's supposed to be a horizon in 15 miles, isn't there? With the camera touching the water.
Yeah, it obviously depends on the trees. Observer.
You can look at the trees on the other side of the lake. It's not like a mountainous area, or it's just flat. And it just doesn't work out for their math for a sphere that size. It just doesn't even close.
The only problem with the doing tests like this, it's always dependent on the atmospheric conditions at that time, isn't it?
Yeah,
Yeah, have you seen Jenna Fredo when she always uses like a lighthouse for a litmus test? You know what I mean? And some days she can see it, some days she can't see it, and it's just a good example of the ever-changing atmospheric conditions. And it's not until you get the atmospheric conditions perfect that you can see further. You know what I mean? Because when it's
actually
when
I've got a video I'm going to put in the background. You keep talking, I'll find it here.
Yeah, it's not until you get them atmospheric conditions perfect that you can actually see further. You know what I mean? And light does play a big part in it. And this is where mainstream is mistaken when they're saying what you're seeing here is a mirage. Yeah, you're not seeing a mirage. You know what I mean? It's always the opposite. From a flat Earth perspective, what you're going to say is that refraction is bending the image downwards. It's mirroring it downwards. What mainstream will tell you is that object is magically rising up from behind the curvature of the Earth. You know what I mean? So you're always banging your head against the.
Just say it was a mirage and it was coming over an horizon. It wouldn't come across flat, would it? It would somehow be curved.
Well, like I say, it's.
Oh, go ahead, Dave.
Go on, Joe.
I was just gonna say, see the house behind me here?
Yeah.
You see the trees coming out of the shore bank there?
Yeah, and the car going past.
Yeah, I'll show you another video of it in a minute, but see how much, refraction and everything, like distortions going on between the camera and the house there.
Yeah.
This is 9.5 miles. The house is 9.5 miles from the camera, but I have another video that I will pull up right now that is just backed up a little bit. Same day, same time. There, you can see it's a little clear. I don't know. I'm right in the way, but you see a vehicle driving on the road, on the ice road, and you can see how it's that's where the level of the water is, and then we can see the vehicle on the road. There's supposed to be a horizon where the earth curves, and then this truck would be a little more buried or down the curve, but nothing ever goes down the curve. Look at the trees behind the house. I mean.
Have you thought about it though? How would you be able to film it if it was going sort of slightly on a curve? Surely the car
you'd
then
have
would
limited
be
everywhere all the time. Would be limited.
Yeah, you can't do that. It never happens.
It would be a strange thing to look at if that was the world. If the world curved down like that all around you in 3 miles or whatever, that you could actually visually see it. No. I'm just saying that's unrealistic, because that you'd feel like you were living on a ball in that case, especially if you're up like on top of a hill. You'd be like, whoa, it just doesn't make any sense.
They've basically twisted the true law of perspective. They've took the true law of perspective and they've turned it into curvature, basically. You know what I mean? Things disappear from a distance because they're converging away from you. You know what I mean? And the reason why boats look like they're sailing over a curve is because the same thing. It's converging because you're on that ground level and it's converging to a point. Yeah,
that's
it will get smaller
that way.
Yeah, exactly.
And that's just the thing is if the sun sets bottom side up, Earth's the ball. And I'm like, now when I look at that, like when I watch a sunset now, think about it again, guys. This should be one. Here we go. Now I got to get myself out of the way here somehow. I got to learn how to do that again. There we go. Whoa, wrong one. Okay. I hit the wrong button or something. I don't know what I did. Whoa, flames coming. Oh, good. They're behind me. They're good. They're behind me. I really don't know what I did. I hit the wrong button, I think. This program's fun. $50. Can't go wrong. It's a lot of fun.
Yeah, it looks fun.
Oh, I don't know what I did there. I saw it for a second.
It's back.
I'm just gonna go in the cupola for a while.
It was back. You had it just a second ago.
I know, and then I think it must be a video that I had 2 clips on or something. I don't know what I did. I did something wrong. I'm still learning how to use it, and I've had it for a long time too. But I'll just relax here in the cupola for a while.
Yeah. So what I'm planning to do next is, because I've got this measuring tool now, I want to basically document that proves that the moon, even though it does look big on the horizon, yeah, it actually measures smaller, and then when it looks tiny, when it's above your head, it will actually measure bigger before it hits its zenith. You know what I mean? Then it starts getting away, and I think that'll be a good thing. That will be a good thing to document, because when a globularis says, well, if the Earth was flat and the Moon was close, then it should be getting smaller as it goes away from you or comes getting close to you. And then the fact of the matter is that it does.
Happened, Dave, because I was that's when we came on the hangout. I said I nearly had a heart attack when I saw the size of the moon in the sky, but you said it didn't measure any different. And I was thinking, really? Look, it was absolutely huge.
It's an illusion, yeah, because you're seeing the moon set against a background, yeah. So it gives you that illusion that it's bigger. Now, when it's right up at the zenith above your head, yeah, it's not set against anything and it looks tiny, but it will actually measure bigger. Trust me, I've measured it enough times now, yeah, to have a pretty understanding that it is definitely an illusion when you see the moon. Because I question that myself. Yeah, I've argued over that with globularis. Bradley Gillen, for a good example, when I've said to you, there's no way that sun and moon is smaller when it's absolutely massive on the horizon. But the fact of the matter is, your eyes are seeing it against the background, and it's that illusion with the background what makes it look like it's actually bigger. But like I say, I've measured it on a few times. Jenna Fredo's measured it as well.
Something to do with that lighting thing that like enslaved medias, like, and that happened to me when I went to the pyramid. You know, when we were up at the fence, there's a field and a pyramid. We were taking pictures, and then we got back to the car, and then suddenly Keith went, "Look at that!" And we looked. Oh my goodness, the pyramid was absolutely huge, and now looked like it touched the fence, but it didn't.
It possibly with objects in the distance, like I've seen wind farms zoomed in at full zoom on my camera, and they look massive. So yes, atmospheric lensing does occur, yeah, you know, with buildings and thingies, but I don't think it occurs with celestial objects. I mean, yeah, I'm 99% sure.
I think you're right. Because oh, go ahead. Sorry, I'm not trying to.
Because every time I've measured the moon, when it's been on the horizon and it looks massive, it's measured smaller. You know what I mean? It's okay, and it's a lot of distorted. The image is a lot more distorted on the horizon as well. You know what I mean? Even though you can get a pretty accurate measuring tool on it, because that measuring tool is like super accurate. You know what I mean? You're talking pixels. You know what I mean? And I'm not. You're talking like.
What is that you use? Is it like it's software, right, or something?
It's software. It's called Bearsoft measuring tool.
Cool.
It's really expensive.
I'll bet.
Oh yeah, like I say, you know, for measuring, because it's got an elliptical measuring tool. Okay. It's perfect. You know what I mean? You can just stretch it round to the edge of the object. If you want to get it super close, you just zoom in on the object really close, and you can get it perfect on the edge. So you can get you can be accurate within a pixel. You know what I mean?
That's good.
Interesting. The sun and the moon, they always measure a pixel wider than they do on the horizontal than they do on the vertical as well. So that's interesting as well.
Even at zenith.
Yes, like I say, every image I've ever, if you go onto my lunar page and you look at all my measurements, what you'll notice, because what I started doing, I started instead of measuring the whole actual image, I started doing it in vertical and horizontal, and the horizontal was always a fraction wider on every single image, even though it looks like a perfect circle. There is like a pixel difference, and every image always measures slightly bigger on the actual horizontal, which is interesting, because they tell us that the globe is oblate, and you probably sometimes I wonder where they get the information from. You know what I mean?
Yeah.
So, but yeah, I think it's a good tool, and you know what I mean. It just puts more information out there, because when people are trying to, whether they'll ever be able to build a model or not, what it does do, it gives you that information to add to it, because you need to take stuff like this into consideration. You know what I mean?
Yeah. I'm definitely glad that just that we're looking, that we're even thinking and talking about these things, because 10 years ago, I believe that I was just scooting through life without believing the truth. I mean, like, this is important thing, and people laugh at it and everything, but it's one of the most important things that a person could look into, because look how many of us have completely left that lie. And even if you think it's true, that's fine. But I'm saying it's a lie. Dave's saying it's a lie, and we've left it. We've turned and we've found the real thing, and we're now learning about it.
Exactly. But like I say, it's you have to take all the information and all the data into consideration, what we're actually collating, you know what I mean? And that's where I try and put it out there and say, yeah, you know what I mean, the moon does appear bigger at perigee, and it is smaller, and I've measured it, and I can back that up with the information, you know what I mean, what I've gathered.
You have the data.
Yeah, with the data. Yeah, you know what I mean. So it's and like I say, all I keep doing now is documenting all the data and saving it all, and hopefully when I put it out there, somebody else with a few more brains can pick it up and, you know what I mean, take it to the next level.
Like, that's how it'll work. I mean, there's a lot of people that grasp certain things really easy, and or they're really good at them, and it'll be like something where someone looks at it and goes, "Oh, I understand that." Something that you put out, and they take your images and your data, and they make like a graph or something, like seasonal or something, you know, who knows. But I just think that everything that we've learned since we've been born has been refuted in the last 3 years.
Yeah, it's amazing. You know what I mean? You can basically I can scrap the last 44 years and just, like, you know what I mean? I've learned more in 3 years than I've learned my entire life. You know what I mean?
Yeah.
I've learned how to use a camera.
It's thanks to people like you as well, Dave, because we're learning from you.
Yeah.
And you, Joe.
Yeah. Yes, and like I say, it's you know what I mean. We keep pushing the envelope of our own abilities.
Your new book's going to be called Dave's Science.
Yeah, Science Man Dave.
Yes, but yeah, I'm quite disappointed with Slime Man Dan, because he's made 3 videos about me now.
Yeah, he's just, you know, I guess I can relate to anyone that lived on a globe, or that lives on a globe. I can relate to them just fine, and I understand that they know what they're talking about. But I'm also telling them that there's more than what they were taught that to look at. Is what I'm saying is, everyone thinks that everything's set in stone. No, it's not set in stone. Science is there to learn, to gain knowledge about things by making observations like Dave's doing, and you know, just playing with the idea of, well, here's the data we have, and this actually goes against what we learned. And so what does it mean? You know what I mean? What does it mean if Dave comes up with a different thing than we've all believed, but he's got the pictures to show it, and he's got like very organized information to look at. And then if someone wants to say, "Oh, well, no, he's inaccurate," well, then do it yourself, and then we'll have 2 that we can compare with, you know. And then 3,
exactly, and that's why it's good. And that's why it's good, like, to team up with somebody like I've teamed up with Jenna Fredo on a number of occasions.
Yeah.
And what we're doing, we're verifying the information or the data. You know what I mean? I'm saying, hey, you know what? The sun actually measures bigger during winter. You know what? Jenna Fredo takes the same shot at a 2000mm optical zoom on the P900, gets the same results. Then you can verify that and say, you know what? Yeah, even though the moon, the sun in summertime is hotter, it actually measures smaller. I mean, this is one of them divine interventions, or should I say, or one of these supernatural things what just probably will never be able to be explained. So
no, I think you're right. You know what though? Let me explain one thing, because something you said a minute ago made me think of a Bible verse in Daniel. I'm reading it. Daniel 12, verse 4. But thou, O Daniel, shut up the words and seal the book, even to the time of the end. Many shall run to and fro, and knowledge shall be increased. Are we in the end?
Exactly.
Something to think about.
But the really great thing is the people are waking up from the program.
Yeah, coming out of the prison house, coming out of the darkness.
Yes, and it's surprising because when I've been on the streets, I went down to Speaker's Corner end of December and met up with Roxanne and Jason Disbury and a few others, and people are more receptible to it these days, should I say? You know what I mean? So when I first went out there, you're literally banging your head against a brick wall, but more and more people are to it. You know what I mean?
They look at you like, oh, really? Instead of, you know. It just seems like, yeah, it's way more accepted, and that's only 3 years. So that's good.
Yes, and if you the stuff what Nathan Thompson does is like it's amazing. You know what I mean?
Yeah.
People don't appreciate what he's actually doing.
He puts himself out there a lot.
He's out there on the front line, basically. You know what I mean? Literally on his own, like a one-man army, and he's. You know what I mean? And say something, he knows his stuff as well.
Yeah, he does.
So
I like seeing him talking to like pastors or like when because Nathan, I don't know, he's good at that. He's good at not, I don't want to say getting in their face because that puts like a negative thing to it. I'm saying he's good at getting the point across, even when they're like, we don't want you to be here. He's like, well, it's a public place. You're on film. You know, I think it's just great. I have a hard time doing that stuff. Like I'm not bold like that.
Yeah, it is. Yes, it is difficult. You know what? Am I in my comfort zone when I'm out talking to people on the streets? No, I'm not. You know what I mean? I'm far from my comfort zone. I'm happy to be behind my computer doing what I want to do. But you know what I mean? If you want to take it to the next level, then I think that is the way to go. Although I'm not going to do it like full time like some of these guys are planning to do this year. You know, with the Globe Live tour, it's a mammoth task to take on, and you've got to, you know what I mean, you've got to have some good stamina to put yourself through that. It's, you know what I mean, talking to people in different towns on a daily basis, you know what I mean, for 3 months. It's got to be draining emotionally and physically, and like
just to be away from home for a while, you know.
Yeah, exactly. And like I say, we're all in his comfort zones when we're sat behind his computers or whatever. But you have to put yourself out there to, like, you know what I mean. You know what I mean. It's, you have to come out of your comfort zone and put yourself in that position. And
you get no sleep, Dave. When you're a flat earther, no sleep. Yes,
like I say, I mean, you know what I mean. I'm up in 5 hours for work, so it's. But I had a good sleep this afternoon because I knew I was probably going to be on a late hangout. So I thought, right, I'll get I had a good 2.5 hours sleep. I literally had my dinner out from when I finished work, so I could come home, literally get showered, jump in bed, get the electric blanket on, and get some shut eye, so I'm nice and fresh for when I
have to do that often. If I've been doing things late at night, I have to have a snooze in the afternoon because of the lack of sleep.
Yeah, because, you know, 2017, literally I was sacrificing my sleep. You know what I mean? I'm talking some serious. I was having like 3 hours a night if I was lucky.
Researching,
you know what I mean?
Right? Researching, learning.
You know what I mean?
That's really great amount of sleep, that is.
When I pumped all the information to my graph, what people don't realize what I did is, I did it all manually. I didn't copy and paste anything from anything. I typed in every single reading manually over the year. Yeah. It took me like 3 weeks to type it all in, you know what I mean? And then I had to convert it to the graph. So I did it all manually first. I don't know if you've ever seen me on my computer in one of my presentations where I'm sat there like a time lapse. I thought what I'd do, I'd time lapse myself doing it. And I literally do the information myself. I'm sat there with like an on-screen calculator, and I'm calculating the time between one point to the next, and then I'm putting that information into the just a WordPad at the time, and then I take the WordPad information and I put that into the Excel spreadsheet. So all the stuff I do manually. I don't just copy and paste from time and date and just stick it all in there. I actually do it physically and, you know what I mean, and manually. So it is like it takes, you know what I mean, you got to sit, you've been at work all day and then you sat on your computer for 6 hours. And it's you know what I mean. It is quite stressful to do this kind of stuff. You know what I mean? But we're all after one
Someone's
thing.
always against you. Always. Like Bert here, just give me trouble all day long when I'm telling him. I'm like, no, it's not curved. And he's like, yes, it is. I'm just playing, trying to have some fun.
Yeah. So, like I say, you know what I mean. I'm sure we've all sacrificed sleep, and we would do it for one reason, just to find out the truth. You know what I mean? Who we are,
and
where we are.
That, you know, that's another thing, that when you learn the truth, like when you start seeing something as a lie, and you actually, like, you notice that, okay, all the people around me are believing this and actually fighting for it. It gives you a drive. Like, I would never have thought 4 years ago that I would ever make a video and put it on YouTube, or, you know, of me, I mean, of talking or of anything like that. I'm like, no, I'm not going to get in front of a camera. But now I'm like, I want to share it so much, you know?
Yeah, that's the same as me, mate. Like I say, who would have thought 3 years ago that I'd be doing a presentation at the UK convention? You know what I mean? It's completely out of my comfort zone, and but if we want to get the information out there, then it's what we have to do. And I don't know if you're aware, but I will be doing a presentation at the New Zealand conference I think it's in like 2 months. So that should be quite. Yes, I'm going. Yeah. Yes.
Wow.
Robbie Davison's going to be there, and so is Mark Sargent as well.
Well, that's what he says anyway. I'm just teasing.
Yes, that's what he says. Yeah. So
I'm joking.
hopefully, I'm just holding back a little bit now. You know what I mean? Just to get the full confirmation and until I commit myself fully. I've just about finished the presentation. It's going to be a little bit similar to the one I did in America, but I'll have more time to obviously elaborate on things where I was a little bit pushed for time. I had to squeeze it all in 20 minutes. Well, I did a 40-minute presentation, which I had to squeeze in 20 minutes, which was really, really difficult to do, really. You know what I mean? Because me and Richard thought we had 40 minutes, and it turned out we had 40 minutes between us. So that was like the day before I was going to travel there. So I had to literally change all my presentation round to fit into that time schedule. And then it was on the back of Rob Skiba's presentation. So it wasn't brilliant, you know what I mean? So like I say, I'm going to get the opportunity to do the full presentation in New Zealand. And like I say, with some of the information that I've got, it can question the globe. You know what I mean? I'm not saying it's right, but what I can do is question the globe. You know what I mean? Ask
people thinking.
Yeah, get them thinking, and ask that question, especially with the eclipse, when the moon stays full at 100% for nearly 12 hours. You know what I mean? If you look at a model of the heliocentric model in motion, and then you ask yourself, how the hell can that moon stay full at 100%, 12 hours? You know what I mean? It moves a long way in 12 hours. You're talking probably nearly 35,000 miles in its apparent orbit. It's a long way for it to stay at 100%. So it's I call it a lunar standstill, basically, because to me that's what seems to be happening. You know what I mean?
I call it lunacy.
Yes, it is very like I say, that we know the word. That's where the actual word comes from.
Yeah,
and
it's like the opposite of what the word should be, kind of a little bit.
Yeah, exactly. And like I say, it's with the moon. You know what I mean? You probably pick the most difficult object to observe because it doesn't really fit in with anything. It does its own little thing.
We only see one side of it, so we really don't know unless NASA sent or China grows some plants on the back, some potatoes or something, right?
Yeah, that just reminds me of that film, The Martian.
Oh yeah,
you know what I mean? It's like a mini version of that, isn't it? It's like they pre-program you with that, and now they're growing silk and potatoes on the moon with the lunar soil.
Was that you, Dave? Was that you, or was that someone else that said I wonder what the pictures from the backside of the moon of the eclipse will, the eclipse would look like.
Yeah, that's why I said. I thought,
Yeah.
you know, with China, because they said they're on the dark side of the moon, but if you look on the actual backside of the moon, they're literally on the south pole, on the moon's south pole. And I'm thinking to myself, if that moon's going to glow red,
yeah,
are they going to see something from there? Because you know what I mean.
It should be like hell, like red on the moon.
Exactly, but
You know
you're not going to.
It looks like they're shining a flashlight through the back of the moon, like God's shining a flashlight through the back of the moon, a red flashlight or something.
Yeah, and it's I never got to. You could probably explain it more than me, Joe, because I've only ever seen one. I've not seen one with my own eyes, so you know what I mean. It'd be good to get your take on what you actually saw that night. You know what I mean?
You know, I did a live video, or I streamed it live on Facebook through my telescope. You probably saw that, or you hopped in there for a little bit.
Yeah, I did. I was hopping in and out of all of them that night.
A lot of them. There's a lot of people putting it on Facebook. That's another thing. Okay, speaking of flat Earth and just the topic of that the cosmology here is not what we've been taught, whether it's flat or whatever. That's not the point. But how many people that have discovered a different world had a camera pointed at the moon live streaming on YouTube or Facebook or whatever, like 10 years ago, and then now, like this eclipse, there was my YouTube feed was just, it was like a moon on every one of the channels. It was
mine and my Facebook. Nearly every single feed on the news was the lunar eclipse, and it just shows you, you know what I mean, how many people now are going out buying a P1000 or a P900 or whatever camera they want to get, and they're pointing towards the sky. Yeah, it's phenomenal. It is. It really is. And I tell you something, so many people got so many pictures of the eclipse, and it would probably be
footage. And I think everyone did.
Yeah, it would have probably been a good time to like take some readings, because you could actually pinpoint the true position of the actual moon. You know, I wonder
if anyone took the temperature of, like, tried to mess around with like that during the
eclipse.
Yeah, I never thought of that till right now.
The moonlight test. Yeah, that would have been interesting. Yeah,
I was standing right out there, man. I should have done it. But when I saw it, all I was saying the whole time, and I said this probably 15 times on that live stream. If from where I'm at, the shadow, or if you call it a shadow, moving up, and so if it's moving up, let's see. I got to get something to. I have a plate here, a little bit of cheese on it. Okay. If it's moving up like this, the shadow is going up like that, like up the moon like that. This side was red. This side was gray. Tell me how that works. That's what I was witnessing the whole time, is the right side. And if this was the sun with the earth in the way, it would be uniform. Unless maybe that was the smog in LA that was on the right side, and then up in Minnesota that was on, you know what I'm saying? It's just ridiculous.
Yeah. That's what they say though, isn't it? That they say it's the actual, they call it the air pollution as well. You know what I mean? The reason why it turned red. It's a load of nonsense. You know what I mean? We all know that if the earth was blocking the sunlight, then we shouldn't have been able to see the moon. Should we really? It would have been pitch black. You know what I mean?
Like I have friends on Facebook that, of course, they want to rub it in, and so they put a picture up of halfway through the shadow or whatever, and they're like, "See the curvature of Earth?" And I'm just like, "You're looking up at a light in the sky, and you're telling me that the ground beneath you is getting in the way of the light from the sun? How does that work?"
Exactly.
It doesn't make sense to me anymore. Like, I just can't see it anymore. I can't see it that way anymore.
Yeah, that's exactly how I see it. And like I say, it is a phenomena, like a supernatural phenomena, what takes place on an eclipse. Because, like I say, the moon remaining at 100% doesn't fit any model. You know what I mean? That in itself is something we need to probably question and look at. Yeah,
and acknowledge, like what you just said. I think that everyone should acknowledge what you just said. that it is something supernatural up in our night sky, especially when there's a eclipse happening like that. And of course, as human beings, we want to figure things out. We want to know, but I think there's a line we need to draw and say, well, up there, we're not going to necessarily know what's going on up there, because that's not for us. Like, that's for us to put light down on the earth, and it's for us to have lights and the sun and the moon, and, you know, a schedule and a clock and everything. But get all these guys, like the guys behind me here, and they're all, yeah, launch rockets.
They've just watched a probe land on Uranus.
Yeah. And they're all pumped about it. They're like, yeah. It's ridiculous. And you know what? Like, I think it should be obvious with all the, like, the Star Wars, Star Trek, this whole era, like ever since I was a little kid, of this space fantasy, the sci-fi fantasy. And now we're in love with teaching our children to imagine. Use your imagination. Yeah, but only in certain areas. You don't want to use your imagination for your reality. It's just
exactly.
We have been. So now we're trying to get back to using our senses instead of our imagination for our reality.
Yes, and Galileo said that as well. You know, I can't remember the exact speech, but it was on the lines of, you know what I mean, if we use our own senses, yeah, you know what I mean, how the hell did we come to a heliocentric doctrine?
Yeah, how did we think that we're spinning? Because we look up and we see the sky spinning. That's a little backwards. I mean, I understand it. Yeah, you could picture it that way, but we don't live up there. We live down here, so that's spinning. That I don't, you know what I mean? Even if it was if Earth was a ball in space and there was all these stars, even still, why would you think it's spinning? Because the Earth is the part that's beneath us, not above us. It's beneath us. So they've got it opposite, completely opposite. And that really bothers me. I talk about that a lot.
Yeah, I noticed that a lot of things they use that the opposite. You know what I mean? A lot of things are the opposite what they tell us. You know what I mean? It's
yeah. Everything in the sky is a sphere, so Earth must be a sphere. That's logical to these people. And then they play pool on a pool table, or they play soccer in a flat soccer field.
Yeah, I use that analogy myself.
Yeah. Well, and I can understand when someone looks up and they're like, well, the sun looks like it's a sphere type thing. The moon looks like it's a sphere type thing. Mars might even look like it's a sphere type thing. Well, then Earth must be a sphere type thing. Like, wait. Don't you realize that when you look up there, you don't see all the living things that you see on the Earth? Like, we have all the grass and the trees and the birds and the water, and we have humans, and this is a life-filled place. And it happens to always have an up and down too. And down's always this way, up's always this way. And it's like really consistently like that. If I turn myself upside down right now, my senses and my ears and my everything, all my senses are going to tell me, hey man, you're upside down. So just the idea that traveling 12,000 miles is going to make you go upside down, and then that's going to be right side up. It's hogwash. There's nothing to base that on. There's no equipment on any jet airliner that shows you that. Oh, maps do. Google Earth shows us. Okay, you live that life then. I'm done with that digital imaginary world.
Yeah, that's well said. Yeah, I totally agree. Right, Karen, I'm going to have to shoot off now because it's getting quite late, and I've got to be up at 4:15 in the morning, and it's now 11:30.
I actually got to get out here pretty soon too.
Well, that's okay. We've been going for 2.5 hours. That's still a great hangout. It's been a very informative hangout, and it's really great because obviously you two are into this. Oh, I've got messages. Sorry, you two are into the same sort of thing, so you can talk to each other, can't you?
Yeah, like I say, you know what I mean? Even though we come from completely different backgrounds, you know what I mean? We can still gel on the same level because we both share the same.
We have truth in common.
Yeah.
That's
We have the truth
something
in
that
common.
all of us have truth in common, and that's why we know each other. That's why we know each other. We're after the truth.
It's been a great hangout, and I've enjoyed speaking. And
Haven't you, Dave?
yeah, and I really enjoyed Patricia's input. She really hit the nail on the head today.
She did. She did.
Maybe you leave Patricia behind, don't you understand? We haven't done the camera work. Oh, look, she's coming in there.
I'm so glad you enjoyed my input, Dave.
Yes, it was amazing as usual.
Yeah.
Yeah, thank you,
Short
Dave.
but
That was
sweet.
cool.
Oh, thank you. Thanks, Patricia. Thanks for everything, Patricia.
Yeah.
Thank you so much, everybody in the chat room. It's been a great hangout. I really think that Dave and Joe really enjoyed that anyway. And Crow came in, and yeah, it was good. It was brilliant. And thank you, Patricia, Joe Hill, and Dave Marsh. We're back. Let's have a look when we're back. We're back Friday this week. Okay, so we'll see you Friday. Mwah. Thank you.
Thanks for having me. Thanks, Joe. Thanks, Patricia, and thanks,
Thank you
Karen.
all.
And keep it flat.
We'll just say goodbye off air, Dave. So don't go for 2 minutes. But anyway, bye everybody. Mwah. Thank you
Bye.
so much.
Love you all.
Oh, I love you too, Patricia.